So today we are going to be solving 100 most difficult MCQs of O-levels and IGCSE chemistry, and these are from the past 5-10 years. And I had to solve a ton and tons of paper to figure out the difficult MCQs, and it took a lot of time. I had to solve the papers myself to figure out what was challenging. So let's get started with the first MCQ. Okay, before starting, I'd like if you do the MCQ yourself so that you know, because tomorrow is the exam, so you know what kind of preparation you guys are having. So solve it before I tell the correct answer, okay? And that's how you're gonna know that where you stand. Okay. A liquid X is distilled from a mixture using the apparatus shown. Okay, so we are shown with a simple distillation apparatus. We have a round bottom flask in which we're kind of heating the liquid. We have a thermometer that's going to measure the temperature, and then the liquid is being distilled over into this receiver, or you can say a beaker. What's basically happening is the vapor that enters is cooled by this cooling jacket or the condenser, okay? During the distillation, the thermometer reads 157 degrees Celsius to 160 degrees Celsius, okay? Now that's a very important thing, that this is the reading on the thermometer. Which information about X is correct? Okay, now X is basically the liquid that is being distilled, and while X is, being distilled into this receiver, this is the reading on the thermometer. We know that when a pure substance or anything distills over, we have one reading, but over here we have three readings, a mixture of readings. So there must be something fishy about this thing, a liquid X. That's why we don't have a single fixed reading. Let's figure out. Option A, the liquids in X may or may not be miscible, mixed with each other. Okay, we are going to look at this option later on, because first let's see other options, because I guess they're more like trickier. X is a mixture that can be separated by distillation. X is a mixture that can be separated by distillation. How is this possible? Look, you have distilled X, okay? You have distilled X from this, and now they say that now X again can be separated by distillation. That is not possible. That you have extracted a liquid from distillation, and now you're thinking of doing the distillation of this liquid again to separate it out. So that is completely incorrect, because once you have gotten a liquid out of distillation, you can't distill it again to separate it again. Okay, X must contain two liquids with a boiling point of 157 degrees Celsius to 160 degrees Celsius. Okay, now statement C seems the most correct, okay, but in fact it is wrong. It seems correct, but it is not. X must contain two liquids with boiling points 157 degrees Celsius and 160 degrees Celsius. Okay, I also thought initially it was correct, but when I studied it and read the marking scheme, this is incorrect. Why is this incorrect? Look, in distillation, in your receiver, you get a substance that has a fixed boiling point. Okay, for instance, I have you just consider I have a mixture of water and ethanol, okay? And now my ethanol has a the boiling point of 78 degrees Celsius, so my ethanol is going to distill over first, okay? My ethanol is gonna distill over first into this thing, okay? Into this receiver, my ethanol has to distill over first. Now, important thing over here is that I cannot say that because my the reading on my thermometer while distilling ethanol was 78 degrees Celsius to 80 degrees Celsius, I cannot say that it is a mixture, okay? Because my reading has to be fixed, okay? My reading has to be fixed. I cannot say that there is water in it as well, okay? Water has to boil at a fixed point, that is 100 degrees Celsius, okay? So until all the water has not boiled, the reading cannot increase from 100. So that is what you need to understand, okay? So this is incorrect. It cannot be two liquids with boiling points of 157 and 160. That is also incorrect, okay? Because if there were two liquids, they both had to distilled at separate points, okay? One would be all distilled at 157, and when the temperature from 157 would increase, at 160 the other liquid would boil. So this is also incorrect. Okay, now third statement, X must have been obtained by the fractional distillation of petroleum. Okay, I don't guess there's any clue that's indicating that X must have been obtained by the fractional distillation of petroleum, okay? I know this is a tricky MCQ. It tricks your mind into thinking option C or D are correct, but unfortunately, all these three, B, C, and D, are incorrect. X cannot have been obtained by fractional distillation of petroleum because that is what we don't know, okay? We cannot just say that a liquid is boiling at 157 to 160, so it is obtained by fractional distillation. That does not make any sense. So option A, by eliminating three options, we get to know option A is correct. The liquid in X may or may not be miscible, mixed with each other, okay? So that is the correct option. You had to eliminate these three to figure out this one, okay? So I know this was tricky, but since we're doing the 100 most difficult MCQs, so you have to bear along, and I'd like if you guys choose your answers before I tell the correct one. Next one. The formula of ammonium metawendate, okay, is NH4VO3. It consists of an ammonium ion and VO3 ions. What are the charges on these ions? Okay, now this might seem a bit confusing, but first thing you have to figure out, okay, NH4VO3. The overall charge on this entire thing, okay, the overall charge, I know many people don't learn the charges on, polyatomic ions like sulfate, ammonium ions, so they don't know. Okay, the first thing, if you even don't know the charge on ammonium, you have to figure out the overall charge on this entire thing is 0, okay, is 0. So whatever the charge on this ammonium ion and this metawendate ion is, it has to be balanced. It has to be equal. Why it has to be equal? Because the overall charge is 0. You have to get a charge of 0. So in order to get a 0 charge, both of these charges should balance out each other. Okay? Should balance out each other. So option C is telling us that ammonium is 3 plus and metawendate is 4 negative. How is this possible? If this is 3 plus, this is 4 negative, then both charges don't balance out each other. The overall charge should be a negative one because you have one more negative thing. The overall charge should be 0. So this is not possible. This is not possible. Now two options are left. Okay. Now in option A and option B, you have to figure out both are equal charges, so both can be possible. And here comes the part of learning that you had to learn that on an ammonium ion you have a +1 charge, and in order to balance out a +1 charge, you should have an equal and opposite charge on this metawendate ion, so it must be a -1. So which makes option A correct. Okay, moving on. Which mass of oxygen gas combines exactly with 16 grams of sulfur to form sulfur dioxide? Okay, I know it's tricky, but you have to understand what's happening over here. You have sulfur dioxide, okay, you're forming it. You need to look at the formula, SO2. And you have to find the mass of oxygen that basically combines with this mass of sulfur, okay? Find the mass of oxygen which combines with this mass of sulfur. Basically, sulfur, if you check out the formula, the mass of sulfur in the periodic table, it's 32. For oxygen, it's 16. Okay. Now we are taking 16 grams of sulfur. I know it's going to be difficult, but try to understand. We're taking 16 grams of sulfur, okay? So what's basically happening is, the mass of one sulfur, okay? Just look at this thing. The mass of one sulfur, this is one sulfur. The mass of one sulfur in the periodic table is 32. We are taking 16 grams of sulfur. That means we are dividing it by 2. So we are taking 16 grams, okay? So we are taking half the mass of the mass, in this compound, okay? Half the mass of the mass in this compound. So in this compound, sulfur 1, the mass of one sulfur was 32. And we are taking 16. That means we're dividing it by 2, okay? I hope this part is clear. Now, moving on to the next part, we have to find out the mass of oxygen that reacts with it. In this entire compound, how many oxygens are we taking? We're taking 2 oxygens, okay? So far clear? We're taking 2 oxygens. So, what's happening is, look, 1 oxygen is 16, okay? 1 oxygen is 16 in the periodic table. 2 oxygen, 16 plus 16 is going to be 32. I hope you understand this, okay? Now, since we took half the sulfur, okay? It's written that which mass of oxygen gas will combine with 16 grams of sulfur. Originally, sulfur was 32. We halved it. So now this is the mass that comes out to be of oxygen. So we're going to half it as well, divided by 2, and we're going to get our answer to be 16 grams. So we're going to take 16 grams mass of oxygen? And the answer is option C. I know it was tricky, all these MCQs are tricky, but they're nice in a way that they give you the chance to practice. Okay, next question. The atomic number of ruthenium is 44. I know this question is going to confuse people a lot. One of the oxides of ruthenium is a black solid, X, okay. 5.79 grams of X contains 1.39 grams of oxygen. What is the empirical formula? Oh, okay. Okay, leave everything, don't be confused by the question. It's simple. What you have to do, you have an element that's ruthenium, Ru, and you have oxygen, okay? Now, what you have to do, you have to figure out the empirical formula. Simple as that. First, you have to write the masses that you have. So, 1.39 is oxygen, so 1.39 is oxygen, and 5.79 minus 1.39, okay? 5.79 was the mass of the entire thing, and out of that 1.39 is oxygen. So what is the mass of this ruthenium thing? Obviously it's going to be 5.79 minus 1.39. So 5.79 minus 1.39, 4.4. So 4.4 is my mass of ruthenium. Now, what most people would do, I know the majority would do, that to find empirical formula, when you have the masses, the next step is to divide the masses by the mass numbers. So for oxygen, the mass number is 16. For ruthenium, what they will do, I know the majority people will think this is what we have to write. This is what we have to divide. We have to divide it by 44, but that's wrong. This is the atomic number of ruthenium. You cannot divide by atomic number or the proton number in a empirical formula question. What you have to take is the mass number below. You cannot divide by 44. That's going to be wrong. So you have to go to periodic table, figure out which element has the the atomic number of 44, and then from that element you have to figure out the mass number and you have to divide by mass number. So let's go to the periodic table. Here we have the periodic table and figure out atomic number of 44. This is the atomic number of 44. And now I have to take this mass that's written. Okay, so this is basically an A-levels periodic table. You just have to take 101. Okay, in A-levels they basically give you decimals as well. So you just have to take 101. So you have to go to periodic table, figure out 44 and then take 101. You have to divide by mass number when you're finding the empirical formula. Okay, remember this thing. So we have to divide by 101. Divided by 101, okay, let's figure out this. Divided by 101, that's going to give me 0.0. Okay, copy, paste. Okay, and for 1.39 divided by 16, 1.39 divided by 16, okay, we have got both our answers. Okay, the next thing is that you divide both of your answers by the smallest the smallest ratio that you get. Okay, over here is 0.04 smaller or 0.08. I guess definitely 0.04 divided by 0.04 divided by 0.04. I guess you get 1:2. Okay, because obviously 0.04 and 0.08, 1:2 is what you're going to get. So that means that that makes RuO2, because for oxygen you got 2. Okay, so RuO2 is going to be correct, which makes option C correct. I know it was difficult, but we have solved it. So now we have another very beautiful MCQ. It's also going to be tough. Okay, just don't be intimidated by these MCQs because they are the toughest from the past 10 years. So don't be worried. Try to solve them by yourself if you want to have a good practice. Okay, the rate of the reaction between magnesium and dilute hydrochloric acid is investigated. The equation shown is this. Okay, equations are the most beautiful things on earth, I guess, because they tell you about the ratios, about all the ratios, the elements or the molecules or whatever thing is going to react. 1 mole of magnesium gonna react with 2 moles of HCl to form 1 mole of magnesium chloride and 1 mole of hydrogen gas. If we don't know this, we know that a metal reacts with an acid to form a salt and hydrogen gas. Okay, a known mass of magnesium is added to an excess of dilute HCl. Okay, the concentration of HCl and the volume of hydrogen produced is measured at regular time intervals. Which pair of graphs correctly shows the experimental results? So if you guys consider that your chemistry is good, I'd love if you guys solve this question and tell me the answer. Okay, I'd be really glad if you solve it yourself and tell me the answer, because it is such a deep MCQ. Look, you have your magnesium in excess. No, you have your known mass of magnesium and you have your acid in excess. Okay, you have your acid in excess, and now what they're asking about is the graph is about the concentration of HCl and the volume of hydrogen. What do you guys think? Which graph is correct? Okay, option A and B have similar graph for the concentration of hydrogen of HCl, and C and D have similar graphs. What do you guys think? Which graph is going to be correct? Okay, try to understand this. Now I'm going to give you the concept of excess and the limiting reactant. Remember, whenever you take anything in excess, okay, any of your reactants is in excess, that reactant is not entirely used up. Okay, that reactant is not used up. Okay, some of that reactant is always left in the conical flask or wherever you are doing the reactions. Okay, so the entire reactant is not used up because you have taken the HCl in excess. Okay, because you have taken the HCl in excess, it cannot be used up. What is this telling you? This end is telling you that entire HCl has been used up, but you have taken the HCl in excess, so all of it cannot be used up. Okay, so this is incorrect. This is correct. Okay, your excess reactant can never be finished up in the reaction, so you must have some amount of HCl left. It cannot come to zero. Okay, so this and this, these two graphs are correct. Okay, now let's figure out about the volume of hydrogen. Now hydrogen is being produced in this reaction, so what's going to happen initially? Look, if this is your graph, what's going to happen initially? You're going to have zero amount of hydrogen, and as the time proceeds, the amount of hydrogen is going to increase, and then the line is going to become flat. Why? Because after some time, the limiting reactant is being used up. Okay, all the magnesium, because you have a known mass of magnesium, is going to finish up, so no more hydrogen is going to be produced. Okay, so it initially hydrogen is zero, and then it's increasing over here. Over here as well, initially it's zero and it's increasing, but over here what's basically happening is it's increasing with an increasing gradient. Matlab, they're telling that as time proceeds, the amount of hydrogen is increasing more, the rate of formation of hydrogen is increasing. That's incorrect. As time proceeds, the amount of magnesium is all going to be used up, and what's going to happen is that not the rate of formation of hydrogen is not going to increase but decrease. So you're going to have a graph of decreasing gradient. This is an increasing gradient. Okay, so you're going to have this graph which is decreasing in gradient, because as time proceeds you have less of magnesium left. That's why your hydrogen is also going to be reduced. So option D is correct. Okay, so now we have another MCQ. Okay, which change involves reduction? Okay, that's such a nice MCQ. Which change involves reduction? Okay, if you really think your chemistry is good, tell me which change involves reduction. Calcium carbonate to calcium oxide. Okay, let's write this equation. We have calcium carbonate, CaCO3, and we're forming calcium oxide, which is CaO plus carbon dioxide. Okay, that's what's basically happening. What do you guys think? Is this reduction? Is this reduction? I don't think so. It's reduction. Okay, the oxidation number of calcium is not decreasing. All the oxidation numbers stay in place. Nothing is being decreased. So this is not reduction. Copper to brass. What are we doing in making from copper to brass? We are just adding zinc to copper plus zinc, and we make brass. It's a mixture, so no reduction. Ethene to polyethene. Ethene to polyethene. What do you guys think? Is this reduction? Okay, this is not reduction. This is addition. Not addition. This is polymerization. Okay, from ethene, you are making polyethene. What you're doing? You're polymerizing ethene, okay, to form polyethene. Okay, you're joining those bonds. Okay, so basically what happens is this is kind of an addition reaction. Okay, this is an example of addition reaction, but this is moreover, you'd say it is a polymerization reaction. Why is this addition? Because you have 3 products. You have a lot of products. You have a lot of ethene, and when you combine them, you form a single polyethene molecule. Okay, so that's not reduction. The last option is sand to silicon. What do you guys think? If you guys think more profoundly, sand, what is sand? Sand is simply SiO2, and sand SiO2 to silicon. What do you guys think? Isn't this reduction? Reduction is loss of oxygen. Sand is SiO2, and this oxygen which was previously with silicon and sand, has been lost from sand. It only becomes silicon. So that is loss of oxygen. So option D is correct, which is reduction. Okay, another beautiful MCQ. Thiosulfate ions S2O3 2 negative react with iodine I2 in an aqueous solution. Okay, that's the reaction. In this reaction, the S2O3 2 negative ions dash electrons and are dash. Okay, firstly you need to realize that, okay, gain of electrons is not oxidation. Okay, loss of electrons is oxidation. So and loss of electrons is not reduction. So A and D are crossed out. Now either C or B or C, okay, and from which we have to figure it out. What's happening with this sulfate, thiosulfate ions, okay? Try to look over here. What's happening is, over here, look at the oxidation number of this sulfur, okay? Look at the oxidation number. You have to figure it out. And if you're good at chemistry, I'd love if you figure it out yourself, okay? This is a -6. Oxygen is a -6 because one oxygen is 2 negative and you have 3 of them, so it's a -6. And to balance out a -6, you need a +6. But you have a 2 negative here. So you're, you should have 2 more negative. So a +4 would do the job. A +4 over here, okay, and a +4, -6 would give me a -2, and that's what I need. So there's a +4 over here, and over here it's a 6 times -2. Okay, 6 times -2, that's -12. To balance out a -12, you must have a +12. But over here, you cannot have a +12. You need a 2 negative, so that's a +10, I guess. And then 10 charge on 4. So what's basically happening is that over here there was a +4 charge on 2. So that's a 2 plus, okay? And over here you have a 10 charge on 4. When you have a 10 charge on 4, okay, you just divide it and that's going to be 2 point something. So that's basically an increase in oxidation number, okay? If you did not understand by this concept, there's even a simpler concept, okay? Just look at iodine, okay? I know this was difficult, but just look at iodine, okay? Iodine is 0 over here and -1 over here. Okay, from 0 to -1. I know that you should all know that this is reduction. If iodine is reducing, okay, if iodine is being reduced, then obviously this thiosulfate thing, okay, must be oxidized, because when one is reduced, other has to be oxidized. So this has to be oxidized, okay? So that was the main concept. And because it lost electrons, it has to be oxidized, okay? So that was the concept over here. Let's move on to this MCQ. Okay. Some medicines contain the magnesium salt of a fatty acid. The fatty acids are members of the homologous series of carboxylic acids and contain one carboxylic acid group. Okay. Contain one carboxylic acid group. What is the carboxylic acid functional group and how many moles of fatty acid react with 1 mole of magnesium? So what does this one carboxylic acid group tells us? It tells us that, look, for example, if I take ethanoic acid, which is CH3COOH, okay, this is my ethanoic acid. So if I react my ethanoic acid with magnesium, okay, right, now we're using magnesium. And if I react to form magnesium ethanoate, you know that the formula of magnesium ethanoate is going to be CH3COO whole raised to power 2, not raised to power. We're going to use 2 ethanoates with 1 magnesium. Why? Because one ethanoate, okay, this is one ethanoate, has a charge of -1 and hydrogen has a charge of +1, and one hydrogen is used to balance one ethanoate, okay, one hydrogen used to balance one ethanoate, okay? So over here magnesium has a charge of 2 plus. So how many ethanoates are we going to take? We're going to take 2 ethanoates, okay? So how many moles of fatty acids are we going to use? 1 mole of fatty acid, okay? One fatty acid. The fatty acids are members of the homologous series of carboxylic acids and contain one carboxylic acid group. Okay? It contains one carboxylic acid. To react with magnesium, we need 2 carboxylic acid groups. I know these MCQs are tricky, but you just have to stick to your basics that with 1 mole of magnesium, we need 2 moles of fatty acids. And the formula is simply going to be, we're going to have the acid functional group, which is COOH, which I guess is this one, making option B the correct one. Okay, next MCQ, sodium sulfate Na2SO4 and sodium hydrogen sulfate NaHSO4 can both be prepared using aqueous sodium hydroxide and sulfuric acid. Okay, equations are the the best things you have, 2 moles reacting with 1 mole to form 1 mole and 2 moles. Okay, and these moles are the most important thing. This is what you call stoichiometry, and that's how you drive your moles. If you know the moles of one thing, you know the moles of the entire thing in things in that equation. Okay, 50 cm cube of 1 mole sodium hydroxide is used each time. Okay, we are given with the volume, we are given with the concentration, and we are told that this is used each time. Which row shows the correct volumes of 1 mole per dm cube sulfuric acid? Okay, sulfuric acid required to prepare a sample of sodium sulfate and a sample of sodium hydrogen sulfate. Okay, now you need to understand one thing. Okay, if you're good with chemistry, I'd like if you guys solve this MCQ yourself and get the answer, but if you cannot understand it, it's fine. You just have to understand one thing. Okay, to prepare 1 mole of sodium sulfate and to prepare 1 mole of sodium hydrogen sulfate, what's happening is, over here you are, each time you have to use this. Okay, each time you have to use 50 moles 50 cm cube and 1 mole. So first let's find out the moles of sodium hydroxide. Okay, so the moles, I know that my moles equal to my concentration into my volume. So 1 times 50, but this 50 has to be divided by 1000 because we always get we have to take in dm cube. Over here we have in cm cube, so it's 1, 2 and 3. So I get 0.050 moles. Okay, so these are my moles of sodium hydroxide. Over here it's 2, it's 1, it's 1 and 1. Okay, I have 0.05 moles of sodium hydroxide, and I try to understand this concept over here. Look, with 0.05 moles of sodium hydroxide, okay, how many moles of sulfuric acid will react? Okay, if I take 2 moles of this, 1 mole will react. Okay, half the moles of sulfuric acid. Okay, we're always taking half the moles of sulfuric acid. So for 0.05 moles of sodium hydroxide, half of this moles will be of sulfuric acid because we're always halving the moles. Okay, half of 2 is 1. Okay, so I hope you understand. So we're gonna half the moles of our sodium hydroxide, which is 0.050, and we're gonna get 0.05 divided by 2, which gives me 0.025. Okay, so I get 0.0525 moles of my sulfuric acid. Okay, now try to understand this. I have 0.025 moles of sulfuric acid, but over here the molar ratio of my sodium hydroxide and my sulfuric acid is 1:1. So equal moles of sodium hydroxide and sulfuric acid. Okay, equal moles of sodium hydroxide and sulfuric acid. Mole ratio is the most important thing. So if I have 0.05 moles of my sodium hydroxide, I'm going to have 0.05 moles of my sulfuric acid as well, because it's 1:1. Over here it was 2:1, so I had to half the moles, but now it's 1:1. So because my sodium hydroxide is 0.05 moles, my sulfuric acid is also going to be 0.05 moles. Okay, so to prepare this sodium sulfate, I need half the volume, because moles and volume, you can interchange them with the ratio. Okay, they have the same almost kind of ratio, and to prepare sodium hydrogen sulfate, I need double the sulfuric acid. So to prepare sodium sulfate, which is this, I need half the volume. Okay, I need half the volume of sulfuric acid. So 0.025, I need half, and of double of that I need for preparing sodium hydrogen sulfate. So over here this is double. I don't need this double, I need this sodium hydrogen sulfate double, because it is 0.05 and the above one is half. So I guess this is 25 and the half of 25 is going to be 50. I know this MCQ was challenging, but you just had to understand the mole ratio concept. Okay, next MCQ. Okay, the monomer CH3CH double bonded CH and CH3, what kind of molecule is this? This is 1, 2, 3, 4, and because the double bond is on the second carbon, so this is butene. Okay, can be used to make an addition polymer. The addition polymer has a chain of carbon atoms joined by each other by carbon double bond carbon. Okay, each of these carbon atoms is also bonded to at least one other atom or group of atoms. These are called side groups. Okay, which statement describes the carbon atoms in the polymer chain made from this? Okay, I'd love if you guys solve this by yourself, and if you can do it, I know your chemistry is going to be really good, but if you can't, don't worry. Okay, now what's basically happening is that you have butene and you're polymerizing it. Okay, to polymerize something, to make an addition polymer, the first step is going to be, okay, I have butene, and if I kind of draw it, what's going to be the structure? It's going to be carbon. Okay, I have my hydrogen, then I have my other carbon. I have two double bond on the second carbon, so my double bond, H, H, and then my other carbon, H, 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 okay, H and H. Okay, this is my butene molecule. Now I have to realize that whenever I am doing an addition polymerization, I need my double bond in the center, carbon, double bond, carbon, and I need my sides empty. I don't need these things on my sides. These are disrupting or kind of, creating a mess, because I have to polymerize from the double bond. So I need double bond in the center. So what I do is, I just take this entire side. Okay, what is this? This is C, H, H and H, which makes it CH3. Okay, this bond is here. I just take this entire side. I take this entire thing. Okay. Wait a sec. Okay. I take this entire thing, and now what I do with this entire thing is I just paste it underneath my carbons. So what I'm gonna do is I'm gonna erase this from here, and I put this CH3 underneath this carbon right here. So this is CH3. I hope you understood that I just took it from here and pasted it here. And similarly on this side I have a CH3. So what I'm going to do is I'm going to erase this CH3 from here and paste it underneath this carbon. So this is CH3. And now I can easily polymerize it. And this is the side chain the examiner is talking about in the MCQ. Which statement describes the carbon atoms in the polymer chain made from this? Okay, which statement describes, and this is the side groups are these groups CH3 and CH3, because when you polymerize you need double bond in the center and nothing on the side. These two sides should be free, so that's why I put my CH3 below and this CH3 below. Okay, so now let's read the statements about this. Every carbon atom in the chain has one CH3 and one hydrogen atom as a side group. Okay, this statement seems correct because we have one CH3 and one carbon atom, one hydrogen as a side chain. So if I now try to extend it, okay, now this is my, the kind of the unit I wanted to make. Now I need to polymerize it. So to polymerize it, what I'm going to do is that I am going to break my, double bond from the center. So I just erase this double bond, and now I extend it to the sides like this, and I draw a repeat unit. Okay, so this is going to be H, this is going to be CH3. I hope you know what I'm doing. I'm just extending it. Okay, so C, H, okay, H and CH3 and CH3 unextended bonds. Okay, if you try to notice, every carbon atom in the chain has a CH3. Okay, this is every carbon atom has a CH3. Okay, every carbon atom in the chain has a CH3 attached to it. The entire line has a CH3 and a hydrogen attached to it as side group. So which makes option A to be the correct one. Okay, I hope you understood this. This was tricky, but you just had to know how to create a polymer. Okay, let's read other options. Every carbon atom in the chain is joined to a CH3 CH side group. That is incorrect. Only CH3 side groups and hydrogen. Okay, every carbon atom in the chain is joined to either two CH3 or two hydrogen atoms as the side. That is incorrect. Each carbon atom just joined to one hydrogen and one CH3. Okay, every carbon atom in the chain is joined to hydrogen atoms only as side groups. That's also incorrect. Okay, a tricky MCQ, but I guess it was a good one, and you had to understand how to make an addition polymer. Okay, an organic compound, P is dissolved in water. The concentration of the solution is 0.1 mole per dm cube and the pH is 3. Okay, a solid is added to the solution and effervescence is seen. Which equation could represent the reaction? Okay, first of all, important bits of information I have. It's an organic compound. Okay, second important bit, the concentration is this. Okay, and third important bit, the pH is 3. I definitely know that this is going to be my organic acid. Okay, this is going to be an organic acid because it's an organic compound. Secondly, the pH is below 5 or 7, that means it's an acid, and a solid is added to the solution and effervescence is seen. Now I know one thing, that acid plus which thing is going to give me an effervescence or gas? Either acid plus metal, which gives me my salt and hydrogen gas, okay, and salt, okay, or acid plus my metal carbonate, which is CO3, is going to give me my carbon dioxide gas, water and salt, okay. So these two reactions with acids are going to give me effervescence. So let's figure it out, which kind of reaction am I looking for. First, I see hydrochloric acid. I cross it out because that is not an organic acid. I need my organic acid. So option B is crossed out. Okay. Second thing I see is that I just try to cross out as many options as I personally can. I see this option. Okay. What I see in this option is, try to figure out one thing. Okay, you know hydrogen is a +1. Okay, hydrogen is a +1. To balance out a +1, you need a -1. So this means if this hydrogen is balanced out by this entire thing, CH3CO2, this entire CH3CO2 has a -1. Okay, this entire thing has a -1. Okay, this hydrogen has a +1 and this entire thing, to balance it out, has a -1. And this potassium also has a +1. You know potassium group 1 has to has a +1. So with the +1, you need a -1. But over here you have two of these. That means it's a -2. So this is incorrect. The formula written is incorrect. So I can cross out option C as well. Moving on to option B. Okay, this is written incorrect. Why this is written incorrect? Again, I told you hydrogen is a +1. To balance out a +1, this entire thing is a -1. Okay, and you know that we need magnesium is a 2+. To balance out a 2+, we need a 2-. So we need to take two of these. Okay, we need to take two of these like this. This is correct. Okay, because magnesium is 2+, this is 2, that means 1 is -1, -1 makes it a -2, and that is what we need to balance out magnesium. Okay, so that was it for this MCQ, making option A the correct one. I know these are confusing, but just try to understand some basic concepts over here, that this entire thing is a -1, this entire thing is a -1, and hydrogen is a +1. Okay, so that you had to understand. Okay, moving on to question 10, which is a very beautiful question. Okay, if you're able to get this right, then you are really, working on your chemistry. Okay, carbonates react with dilute acids to produce carbon dioxide. A student uses excess carbonate. Okay, one important thing in graph questions, excess word is the most important word. Why? Excess word tells you either your graph is going to stay on the same line or it's going to move up. Okay, because if I increase my excess reactant, okay, this is my original graph. For instance, this is my original graph. I increase my excess reactant, my graph will not change. Why will my graph not change? Because increasing excess does not increase the product. Increasing excess reactant never increases the product. Okay, we have excess carbonate and we have 100 cm³ of 0.1 mole per dm cube of acid, and measures the volume of the gas produced as regular time intervals. So acid is the limiting reactant. Okay, acid is the limiting reactant. The results give line X on the graph. The student repeats the experiment using 50 cm³ of 0.2 mole per dm cube acid whilst keeping everything else the same. Okay, now what the student has done, first we have to check out the moles of this and the moles of this, of the second experiment. So first, let's find out the moles of the first experiment. It's going to be simple. We just multiply our 100 with 0.1 divided by 1000. So 100 times 0.1, 100 times 0.1 divided by 1000, and that gives me a 0.01 moles. So for my first experiment, I have 0.01 moles. For my second experiment, it's 50 and 0.2. So 50 times 0.2 to get, that's the volume, that's the concentration. You just multiply both, divided by 1000. So 50 times 0.2, 50 times 0.2 divided by 1000, and I get 0.01 moles. 0.01 moles. So look, acid was the limiting reactant, and the limiting reactant moles are same for both experiments. That means my product is, this X is my original line. That means that the line for my second experiment, which line shows the results of second experiment, is going to be leveling off at the same line. Okay, so either it can be B or it can be C. But now I have to understand one thing. I have 0.1 mole of my acid in the first experiment, and I have my 0.2 mole per dm cube acid in the second experiment. I have doubled the concentration. And increasing the concentration increases the rate of the reaction. Okay, increasing concentration increases the rate, and when my rate increases, my gradient becomes steeper. Okay, tell me one thing, is this gradient steeper or this gradient steeper? Okay, tell me, don't look at this line, just tell me about these two lines, which gradient is steeper? Okay, the more flat the line is, the less its gradient. So this is a less steep gradient, and this is a more steep gradient because it is more upwards. So I need a steeper gradient because my reaction rate increased because I doubled the concentration. So option B is going to be correct. Okay, if you're able to get these MCQs right before I tell the correct answers, then you're on the right path. Okay. Oh, this question is extremely interesting. Okay, if you're able to get it right, I am gonna, give a salute to you guys for doing it right. Please do it before me. Okay, universal indicator contains several dyes. Okay, the reversible reaction of one dye INDOH is shown. Okay, a reversible reaction by given with a few drops of universal indicator solution. Okay, this is the universal indicator solution. You're adding H plus ions to it. You're forming this IND plus 1 and H2. Okay, a few drops of universal indicator solution are added to 50 cm cube of water. A few drops of dilute hydrochloric acid are added to the solution. Which row describes what happens when the acid is added? What do you guys think? What happens when the acid is added? This question is really tricky. Okay, you're adding an acid. And when you add acid, what kind of thing are you increasing? You're increasing H plus ions. Okay, when you're adding an acid, you are adding H plus ions. Okay, and when you're adding H plus ions, you're gonna think that the pH is gonna decrease. Okay, the pH is gonna decrease. Which row describes what happens when the acid is added? You're gonna think pH is gonna decrease. Okay, pH decreases because acid is added. Acid is added, so pH is gonna lower. But color of the solution shift towards, what do you guys think? Color of the solution, more of acid is added. So the color of the solution, it's an equilibrium. And equilibrium tries to reverse everything you do. So when you're going to increase the acid concentration in order to decrease it, equilibrium is going to shift towards Y. Okay, so equilibrium is going to shift towards this color Y. Okay, I hope you understand this, because we have tried to increase this thing. So equilibrium, in order to decrease it, is going to make more of the product. So it's going to shift towards colored Y, and pH is going to decrease because we have added an acid. Okay, moving on. Two gases react inside a vessel, inside a sealed vessel. Okay, which change in the conditions would increase the rate of the reaction? Increasing the pressure inside a vessel. What do you guys think? Is it going to increase the rate? Yes, for sure, because increasing pressure for gases increases the rate. So this is going to increase rate because this is going to increase the frequency of collisions. Particles are going to collide more frequently when you increase the pressure on them. Increasing the temperature inside the vessel. What do you guys think? When you increase the temperature, the particles gain kinetic energy. Okay? The particles move faster, and when particles move faster, they collide often. So your rate increasing. Increasing the volume of the gas. Just because of the statement 3, I added this question in this file. Increasing the volume of the gas. Okay, you increase the volume of the gas. That means you have more of the gas, so more collisions. Don't you think this? That's going to be correct, but that's incorrect. Why? Because look, what you're doing is you're increasing the volume of the gas. So what you're trying to do is you're decreasing the concentration. Okay, volume and concentration are inversely proportional. I'm going to explain you like this. You have this container. Okay, you have this container, and what you do is, first you have 10 particles. Okay, you have 5 particle functions. 1, 2, 3, 4, 5, and these 5 particles are here. So they're going to collide more frequently because they have less volume, okay? They have this volume of, for example, I say 20. So right here, this is 20 centimeter. So the volume is this. But when you increase the volume of the gas, when you increase the volume, what you do is you move your piston upwards like this, okay? So now your piston is moved upwards, something like this, okay? So now you've moved your piston upwards. So what happens is that your particles, now these 5 particles have a greater volume. The volume from 20 increased to, for instance, I say 60, okay? What happened? Because the volume increased, volume of the gas increased, now particles are less concentrated, okay? That means that there are going to be less collisions between the particles because you have more space. So what's going to happen? Particles are going to scatter out and collide less frequently. Okay? So your frequency of collisions are going to decrease. And if you don't understand by this concept, just remember volume is inversely proportional to concentration. So whenever you increase volume, you are decreasing the concentration. And when you decrease the concentration, what's happening is that you're decreasing the frequency of collision. So option 3 is going to be incorrect. What's the correct answer? It's going to be option 1 and 2, which is correct, which makes option 1 and 2. So that's gonna be option B. Okay, I hope you understood this. Okay, catalysts change the rate of chemical reactions. Okay, okay, if you're able to do this question, you really have a good concept of catalyst. These are all the questions that are gonna check your concept. Okay, catalyst increases the rate of the reactions. We know which statement correctly describes the effect of adding a catalyst to a reaction. All reactant particles have more energy and move faster. Completely incorrect. Catalyst does not make your particles move faster. Catalyst does not increase the kinetic energy of the particles. Catalyst, what does is it decreases the passing marks. For instance, I give you an example, a very easy example. Just try to, this example is going to help you. For example, I say out of 40, if you get 30, you pass. Okay, out of 40, if you get 30 marks, you pass. Okay. So now only 5 students pass the test because all the rest of students get less than 30 marks, okay? Now, what a catalyst does is, it decreases the passing marks, okay? It decreases the passing marks or the activation energy. Now, if I add a catalyst to these marks, what's going to happen? Catalyst is going to make the passing marks 20 out of 40. So now the passing marks are 20 out of 40. So now, previously 5 students were only passing, but now my 15 students or 16 students passed the test. So it does not increase the marks of the, did it increase the marks? No. A catalyst did not increase the marks of the students. It did not increase the kinetic energy of the particles. What it increased was it lowered the activation energy, okay? It lowered the marks, it lowered the passing marks, okay? I hope you get this concept, okay? This is a very easy way to explain the working of a catalyst. सबसे पहले 30 पे पास हो रहे थे, अब आप 20 पे पास हो रहे हो, ठीक है? तो ज़्यादा बच्चे पास होंगे, so more particles react, okay? A higher portion of the class, the children or the students in the class are gonna pass now, okay? So that's what catalyst does, decreases the minimum requirement, lowers the activation energy, or you can think lowers the passing marks, okay? All reactant particles have more energy, not more energy. The activation energy is lowered. That is what catalyst does. It lowered the marks. It lowers the activation energy. Okay, more reactant particles collide with enough energy to react. That's correct. More particles are going to collide with enough energy to react. More will be able to react. More students will pass the test. Okay, so it's option 2 and 3, which is option C. Okay. Another MCQ. 2 aqueous solutions, Q and R, have same concentrations in mole per dm cube. Okay, we have Q, we have R. They have similar concentrations. Solution Q contains 4 grams of NaOH in 500 cm cube of solution. What solution could be R? Okay, I guess that's easy. Okay, if you're able to do it before me, that's great. Because they have the same concentrations, first we're going to find the concentration of this, and then we're going to match the concentration of this with all these concentrations. Okay, so now we have 4 grams of NaOH. First we find the moles. Moles equals to mass upon mr. Mass is 4. Mr of NaOH is 40. That's not given over here, but I just calculated it out. So 4 divided by 40. 4 divided by 40, that's 0.1. Okay, I have 0.1 moles, and you know that moles divided by my volume, which I'm not going to take 500, I'm going to take 1, 2, 3, 0.5. Why 0.5? Because it's in cm cube, volume taken in tm cube. So 0.1 divided by 0.5, my concentration comes out to be 0.2 mole per dm cube. Okay, this is my concentration of solution Q. Now I have to find the concentration of all these solutions, and whatever concentration comes out to be 0.2 moles, that's going to be my solution. Okay, 0.2 mole of 250 cm cube. Okay, what you have to do, simple apply the formula that concentration equals to your moles divided by your volume. So I'm just simply going to do it. 0.2 divided by 0.25. Okay, 0.2 divided by 0.25, that comes out to be 0.8 mole. So this is 0.8 mole. Okay, one important thing, don't take the volume in cm cube, you have to take it in dm cube. Okay, next is 0.2 divided by 0.1, which gives me a 2 mole per dm cube. Okay, next is 0.05 divided by 0.25, 0.05 divided by 0.25, which gives me 0.2 mole. So I get 0.2 mole, which makes option C the correct option. Okay, another very beautiful MCQ. If you're able to get it right, then you are really going good. Okay, 25 cm cube or 1 mole per dm cube sodium hydroxide is titrated with dilute sulfuric acid using a suitable indicator. 25 cm cube of sulfuric acid is required to reach the endpoint. What is the concentration of sulfuric acid and what indicator is used? Firstly, what are we doing? We are doing a titration, okay? We are titrating sulfuric acid with sodium hydroxide. We are titrating. So for titration, we never use universal indicator. So universal indicator options crossed. Why don't we use? Because universal indicator has a lot of color changes, okay? It has... So too many color changes basically confuse us to know what is the endpoint. So we use an indicator that only has 2 color changes, one in acid, one in alkali. So it's going to be methyl orange. Second thing, what's going to be the concentration, 0.5 or 2? Okay, this might confuse you guys a little bit, but another important concept comes over here. Just try the kind of equation for sulfuric acid, and I guess it was NaOH. What is it? Sulfuric acid is required with sodium hydroxide, so it is NaOH. Okay, NaOH plus H2SO4. Okay, it forms Na2SO4. Okay, plus H2. Now one thing you must realize over here, that what's happening is that because when we balance this, because we have 2 over here, we're going to just add a 2 over here, okay? And then to balance it out, we're going to add a 2 over here, okay? That makes 4. Okay, so this is the complete balanced equation. And I told you the balanced equations are the best thing. 2 moles of NaOH will react with 1 mole of sulfuric acid. Okay, 2 moles of NaOH will react with 1 mole of sulfuric acid. So now 2 moles of NaOH will react with 1 mole. Okay, how many moles over here do you have? How many moles over here do you have? You have a 25 cm cube. You just have to multiply it, which I get, you're gonna get 0.25 moles. Okay, moles equals to concentration into volume. This is your concentration, this is volume, so you're gonna have 0.25. okay, you have 0.25 moles over here. Okay, and for instance, now what's other important thing is that you're not given with these are the moles. Okay, let's find it out the traditional way, but I'm going to tell you another way. This is 0.25 moles. So with 0.25 moles of sulfuric NaOH, how many moles of sulfuric acid are going to react? 0.25 moles. Obviously 2 moles of this react with 1 mole of this. So if you do molar ratio, NaOH ratio sulfuric acid, it's going to be 2:1. And if you have 0.25 moles of this, you're going to have X moles of this, and X will come out to be 0.005, I guess. Let's do it. 0.25 divided by 2 Okay, 0.125, I'm so sorry. 0.125. So these are your moles. Okay, now you have the moles and you have the volume of sulfuric acid. What you do to get the concentration? Moles divided by the volume. So concentration equals to moles divided by the volume. Moles are 0.125 and volume is this. You don't take in cm cube, you take in dm cube. So it's going to be 0.025 in dm cube. So divided by 0.025. So divided by 0.025 and it's again, sorry, it's not 0.0, it's 0.123, I guess it's 0.00. So 0.125 divided by 0.0025. Second, what I'm doing is I'm doing something wrong. Second, I just had to take second 25 divided by 1000, 1, 2 and 3, so 0.025. so second, okay, 0.125 divided by 0.025. 0.125 divided by 0.25. Okay, now it's correct. Sorry. I guess I just made a mistake in dividing it by 1000, 1, 2 and 3. So it's coming out to be correct, but I guess that was the main error. It had to be 0.25. Okay, 0.25 exchange divided by 2. Second. Okay, so that's how you have to do it. Okay, and that is going to result in 0.5. But one important way, this is a lot of working, okay, and you don't have time to work this much out in exams. So what are you going to do? Okay, this is a lot of hectic working, a lot of calculated work, and we don't like because we are lazy people. So this is going to be a lot of working. What I do, simply I just solved it in 2 seconds by just looking at one thing. NaOH and H2SO4. Okay, I just looked at this. I know hydrogen ion double. Okay, hydrogen ion double. I have double the hydrogen ion. Okay, and I have same volume. Because I have more hydrogen ions, my concentration is going to be half. That's only, I promise, I just looked at this and I realized that because this is the volume for both NaOH and H2SO4 is same, and because I have double hydrogen ion concentration, so my hydrogen ion concentration over here, so how many concentration of sulfuric acid I'm going to use? I'm going to use half the concentration. So it's going to be option A. I just looked at this. I just did all that formula thing for you guys to understand. But what I used personally was just this. And if it was HCl, because HCl just has 1 mole of hydrogen ion. So for HCl, I'm going to use simply 1 mole per dm cube. Okay. So that's simple, I guess. That formula was way too confusing. Okay. So you just had to look that because the hydrogen ions in sulfuric acid are doubling, it's a more strong acid, so you're going to take half the concentration. Okay, and methyl orange, because in kind of the titration experiments you never use universal indicator. Okay, what is the structural formula of propyl methanoate? Simple. What is going to be the structural formula? You just need propyl on one side, methanoate on one side. Where to break the ester? Break it here after double O. Break it here, break it here, and break it here. This part that has double O, okay, break it after double O, okay. This part that has double O is going to be your acid part, because the acid part has 2 carbons, so it is going to be ethanoic acid, and this has 1, 2, 3, so it is going to be propanol, okay, propanol. And I know I need propyl methanoate, so this is going to be that's incorrectly written. Okay, ये तो B तो होगा incorrect, because आप देखें इस कार्बन की valency fulfill नहीं हो रही. This carbon is not fulfilling its valency. It's attached to 1 oxygen and 1 carbon. How is that possible? That's impossible. ये possible है, फिर यहाँ पे double bond आएगा और यहाँ पे भी double bond आएगा, और अगर यहाँ पे एक दफ़ा double bond आ गया तो ये ऑक्सीजन इस ऑक्सीजन के साथ कैसे bond कर सकता है? क्योंकि ऑक्सीजन तो सिर्फ 2 ही bonds बना सकता है ना, तो that's incorrect. Okay, अगर हम इस पे आ जाएँ तो this one is my acid, which is propanoic acid, and this is my alcohol, which is methyl. So this is methyl propanoate, not methyl propanoate, sorry. Methyl propanoate, and this is my 1, 2, 3, this is okay. I had to break it from here. Okay, sorry, I had to break this one from here. So if I break it from here, now I get this is gonna be my methanoic acid, and this one is gonna be my propyl methanoate. Okay, propyl methanoate to ban gaya. Now one important thing, how did I know that I did not have to break it from here and here? Try to understand. If I break it from here, okay, if I break it from here, and this is my alcohol part, okay, this is my alcohol part. This cannot be my alcohol part. Why can't this be my alcohol part? Because the valency of carbon is not being fulfilled. Because imagine you have this carbon in alcohol, you have this carbon, and you just have one hydrogen attached to it. That's incorrect, because in alcohols you have 3 hydrogens. This could only be an acid part. Why could this only be an acid part? Because look, this is carbon, and because if I double bond O, H and O, this is how my valency of carbon is being fulfilled on this side. Okay, I know these concepts are a bit challenging, but you have to understand it. So it's gonna be option D. अच्छा, अब इस वाले में भी हम ज़रा ना वो ट्राई करते हैं, दूसरा मेथड ट्राई करते हैं. देखें, अगर हम इसको इधर की बजाय इधर से ब्रेक कर दें, so is it now fulfilling the valency? No, still this is incorrect. Okay, so it's option D, which is propyl methanoate. Okay, which equation is correct? This is interesting. Which equation is going to be correct out of all of these? What do you guys think? Oh, firstly, I just love crossing out equations. Boom, this is crossed. Zinc nitrate written wrong. Zn has a charge of 2+, so it has to be NO3 2. Second equation I love crossing out. This is wrong again. Nitrogen has a charge of 1+, so Na2O, because oxygen is 2 negative. Okay, now I have 2 equations left. Copper and oxygen, and magnesium and this sulfate thing. Out of these 2, which is going to be correct? Obviously this one. Why this one? Because this is incorrectly balanced. I have 2 coppers on this side. I had to put a 2 over here. So it's option B. Okay. Compound X is a gas at room temperature. Okay, if you are able to do this, I'm gonna, accept you guys as genius, because this one is a really difficult one. Compound X is a gas at room temperature. Okay, it's a gas at room temperature. Each information is like a diamond. It's very important. X dissolves in water to give a solution of pH 4. Okay, X is soluble in water, will dissolve to give a solution of pH 4. Which statement about compound X is correct? Okay, let's start reading from D. X is ionically bonded. What do you guys think? Can a compound be a gas at room temperature and ionically bonded? Ionic solids have high melting and boiling points. At room temperature, they cannot exist as gases. At room temperature, they have to be solids. So, boom, this is cross. Okay. Atoms of hydrogen are present in X. We're going to come at it later, okay? Let's come at it later. Option B. Atoms of metallic element are present in X. What do you guys think? Are atoms of a metallic element present in X? If atoms of a metallic element are present in X, why should it be a gas at room temperature? Why should it be a gas at room temperature? Because I can't remember of, metallic elements present and gases at room temperature, because if metallic elements are present, then it will form an ionic bond. And if it will form an ionic bond, then it cannot be a gas at room temperature. It has to be a solid. Ionic compounds are not gases. So boom. An aqueous solution of X will not conduct electricity. Who told you that it will not conduct electricity? It will conduct electricity. It dissolves in water and gives a solution of pH 4. When it gives a solution of pH 4, we know that it will have H plus ions, because this is not a neutral pH, this is an acidic pH. And when it will have H plus ions, it will conduct electricity because it has ions. So this is also incorrect, and this one is correct, that atoms of hydrogen are present in X. Why atoms of hydrogen? Because it has a pH of 4. That means H plus ions are present in it. And if H plus ions are present, it surely has atoms of hydrogen in it. Okay, so option C is correct. Okay. Again, a very interesting MCQ. If you're able to get this right, you're gonna genius, because these are really the hardcore ones. Okay, volume of gas is produced by a reaction of, each word is very important, 100 cm cube of hydrochloric acid. What is in excess? Calcium carbonate. So now, amount of my product does not depend on excess. Excess is just something that does not increase the amount of product. If I increase my HCl, my product is going to increase, okay? If I increase my HCl, my product increase, because HCl is the limiting reactant and the product only increases if you increase the limiting reactant. If you increase the excess, no effect on the product, okay? Now the volume of gases are measured at RTP shown. Okay, we know that we're taking a carbonate and an acid, carbon dioxide is going to be formed. Okay, now we have two experiments. Now, which one change in the conditions to experiment 1 gives the results in experiment 2? Let's see. Firstly, in experiment 1, I have produced 50 cm cube of gas. In experiment 2, I have 75 cm cube of gas. The first thing that I know is that my acid has been increased. Magnesium is not increased because magnesium is in excess. Increasing magnesium cannot increase my amount of gas produced. Increasing the acid, the limiting reactant, is going to increase my gas. So first thing I know that my gas has the concentration, the amount of my HCl has been increased. Okay. Now the second thing I know that in the first 30 seconds, my reaction 1 produced 20 cm cube of gas. Reaction 2 produced 30 cm cube. That means something has been done which has increased the rate as well, because this is faster, okay? More gas produced and the more amount produced in the same amount of time. In same 30 seconds, reaction 1 produced 20 and reaction 2 produced 30. So what has been done? Firstly, something has been done to the acid, because acid is the limiting reactant, and when you increase the limiting reactant, you increase basically the amount of your product. Okay, first let's read the temperature of the acid is higher. If the temperature is higher, the rate is going to be faster, but more product cannot be formed. Over here the product has increased. Okay, increasing temperature can increase the rate but not the product. Rate increases but product only increases because of the limiting reactant. Smaller pieces of calcium carbonate are used. Smaller pieces will increase the rate but not the product. Now option A and B. Can any genius tell which one is going to be correct? I love this MCQ so much. Let's see it. Okay, a greater volume of acid is used and a higher concentration of acid is used. I told you something has to do with the acid because acid is the limiting reactant. Many of you might think option A. Okay, let's see. A greater volume of acid is used. Do you know one thing? If you're making tang, okay, for instance, if you're making tang, you know the tang is basically that orange kind of thing what you make at home. This is your jug and you're making a tang, okay? You add 1 spoon of tang powder, okay? 1 spoon of tang powder, okay? This is your tang powder, and you take this much amount of water, okay? Half jug of water, okay? Half jug of water and 1 spoon of tang powder. And now I ask you that please, I need more tang. I love tang, so let's increase the amount of tang that we make. So we take the same jug, and I cannot afford a lot of tang, so I just take 1 spoon of tang again, and this time I do something very clever. I add the entire jug of water. Okay, I have made 1 jug of tang now. Over here as well, I added 1 spoon of tang. Over here as well, I added 1 spoon of tang. But over here, I took half the jug. Over here, I took 1 entire jug of water. By just looking at it, you know this one is going to be more tasty because it has more amount of tang, and this one is not going to be tasty at all because though the volume has been increased, the volume of tang has been increased. I have more volume in it, but the amount of my tang remained the same. Okay, the amount of my tang remained the same. So even if you increase the volume of acid, the amount of your acid remains the same. Okay, the amount of your acid remains the same. So your product cannot be increased by increasing the volume because the amount of tang that you used in both experiments were exactly the same. You just increased the amount of water in it. I hope you get it. So option B, A is also incorrect. A higher concentration of acid is used. You need to increase the amount of your tang to increase the amount of product. So now if I add 2 teaspoons of tang, even though my volume is same, I add 2 teaspoons of tang, that is going to increase. This is another 1 teaspoon addition. That's going to increase the amount of product. ठीक है, if I increase the amount of limiting reactant, not the volume, okay, because increasing the volume means the amount is the same. What you do is you just add more water to it, okay. So I hope I tried my best to explain as good as possible, making option B the correct one, that you had to use a higher concentration of acid. Moving on, iron 2 ions react with chlorine, okay. Iron 2 ions react with chlorine. Which statement about the reaction is correct? We have to find the limiting, not the limiting, the oxidizing and reducing agents. Let's check out. Okay, over here we know that from 2 plus we're going to 3 plus, okay. That is an increase in oxidation number, and that means we are undergoing oxidation, and whatever undergoes oxidation is the reducing agent, okay. Over here we know that chlorine is in elemental form, so the charge on it is going to be 0. From 0 it's going to a -1, so because the oxidation number is reducing, so that is reduction, and I know that whatever substance undergoes reduction is my oxidizing agent, okay. So that's what I had to do. Now let's read. Chlorine is reduced by iron 2 ions, okay. Iron 2 plus ions, okay. Chlorine is reduced, chlorine is reduced by iron 2 plus ions, that's correct. देखिए क्लोरीन रिड्यूस हो रहा है 0 से +1 पे जा रहा है, और किसकी वजह से हो रहा है? बिकॉज ऑफ द reducing agent has reduced chlorine, and reducing agent is iron 2 plus ions, okay. Now let's read other statements as well. Chlorine is the reducing agent, okay. No, chlorine is the oxidizing agent. Iron 2 ions are reduced by chlorine. No, iron 2 ions are oxidized by chlorine. Iron 2 ions are the oxidizing agent. No, they are the reducing agent, okay. So this concept confuses people, but you just have to just write above what kind of thing you're dealing with, okay. Oh, this MCQ is also one of my favorites, okay. Isoprene is an alkene which is commonly found in plants. Please try to do it yourself before I tell. Which properties does isoprene have? It burns in air, it can form polymers, it can decolorize bromine. Cross. What do you guys think? Or tick. Are these correct? Are these wrong? Or what's the thing is? Important thing, it's an alkene. We need to I don't know what isoprene is, okay. I've never seen it, so I don't know what kind of thing it is, but I know it's an alkene. I'll stick to the basics, okay. I know that alkenes can burn in air, alkenes can combust, okay. So option A is going to be correct. It can burn in air, it can combust, it can undergo combustion reactions, it can form polymers. I know that alkenes can form my addition polymers. Addition polymers are formed by alkenes, so this is correct. It can decolorize aqueous bromine. I know that my alkenes can decolorize my aqueous bromine when the double bond breaks and bromine attaches to each carbon, so it's going to be option A, okay. Oh, this MCQ is also extremely good. All these graph MCQs are very good, okay. Okay, if you're able to solve it before me, that's great. I'd love if you guys solve it yourself. Okay, 25 cm cube of 1 mole per dm cube hydrochloric acid reacts with 10 gram of solid to produce a gas. Important thing, you have this amount of your HCl, you are reacting it with 10 grams of solid to produce a gas. The solid is in excess. Okay, what did I told you? Why do you think in a question like this they tell you the excess? They tell you the excess because they just try to tell you that if you increase the amount of excess, okay, if I increase the amount of my solid, the gas is not going to increase, okay. If this is my original curve, this P, if I increase the excess amount, my amount of gas is going to remain the same. But if I increase my acid, my gas is going to increase, okay. Remember, if you increase the amount of your limiting reactant, the amount of gas is going to increase, the product is going to increase. But if you increase the excess, nothing happens to the product, okay. The graph labeled for the first experiment shows the volume of the gas produced over time. Okay, this I guess P is going to be the first experiment. No, this is not the first experiment. This is what they've labeled as the first experiment, okay. Okay, the graph labeled first experiment. Graph P and Q show the volume of gas produced under different conditions, okay. What happened in P and Q? Can any one of you tell me? P has a steeper gradient. That means either for P you have used a higher temperature, but the amount of your acid or the concentration, volume, everything of the acid is same. The moles of the acid are not changing, okay? The moles of acid are not changing. Either you increase the concentration as well, but the moles have to remain the same. Then you have to decrease the volume, okay, because you have to keep the total amount of moles of the acid same. So either using smaller chips of the solid or whatever you're doing, you're increasing the rate because this is steeper line, but you are not increasing the limiting reactant. For Q, definitely you are using less amount of your acid. The moles of your acid have halved because this is half of this. Okay, what changes in conditions produce graph P and Q if all of the conditions are kept the same? P uses a catalyst and Q has a lower temperature. Okay, P uses a catalyst and Q has a lower temperature. That's incorrect. Why that's incorrect? Q does not only has a lower temperature, it has a less gradient, that means lower temperature, but less amount of acid. It need to have less amount of acid. Why? Because acid is the limiting reactant. I need less amount of it because my less product is being formed. So that is incorrect. Okay. Where are the rest? Okay. Now let's do it. Okay. P uses to move it above like this. Okay. Okay. Next option A was incorrect. B. P uses 25 cm cube of more concentrated acid than Q uses smaller pieces of solid. Okay, that's also not correct. Why? Because that has to be incorrect. P uses 25 cm cube of more concentrated acid. If you use more concentrated acid, though your product, your rate is going to increase, but uses smaller chips, not smaller pieces, uses less amount of acid. Okay, less amount of acid will decrease the product. Okay, P uses higher temperature and Q uses 25 cm cube of more dilute acid. That's correct. Option C is correct. The acid has been diluted. Why acid has been diluted? Dilute acid means less amount of tang. Okay, you just have to try to think about it as tang or roofs or anything. Less amount of tang or less amount your acid. And when you use less amount of your acid, because it's dilute, you're using less amount of it, so less of your product is going to be formed because acid is the limiting reactant and amount of the product depends on the limiting reactant. I tried my best to explain this. I hope you understood this. P uses smaller pieces. No, it cannot be possible. P has a greater rate, so okay, smaller pieces of solid, and Q uses larger pieces of solid. Okay, that could be correct, but you had to also take in account less amount of this gas produced, which means less amount of your acid, which means more diluted acid, less amount of acid in the acid. Okay, I hope you get it. Moving on, two particles have symbols, this and this. Okay, which statement about these particles is correct? They can contain the same number of electrons. Let's calculate the number of electrons. Okay, 26 and 2 plus means 2 electrons lost, so 24 electrons. 27 plus means 3 electrons lost, so 27 minus 3 is going to be 24. So both have same number of electrons. That's correct. Okay, they contain the same number of neutrons. I hope that's incorrect. Just try to subtract and find. They're going to be incorrect. They contain the same number of protons. That's completely incorrect. It contains 26. It contains 27 protons. Okay, they contain the same number of protons, neutrons, and electrons. No, proton is not the same, so it has to be incorrect. Option A is correct. Okay, two isotopes of chlorine. That's a really, really, really good MCQ. Two isotopes of chlorine, chlorine 35, chlorine 37. Okay, using the isotopes of carbon 12 and hydrogen 1, how many different relative molecular masses are possible for the compound with the molecular mass of this? Okay, would any one of you love to answer this? Okay, if you are able to do this, then you are really doing good in chemistry. Okay, this is what you have to make. You have 3 chlorines in it. Okay, try to understand it like this. You have 3 chlorines in it. Okay, 3 chlorines in it means that one chlorine is 35, one chlorine is 37. You have to make different relative molecular masses. Okay, that is your job. You have to create different combinations of 3 chlorines. Okay, I have this 1 chlorine, okay, 2 chlorine, 3 chlorine. I need to create different combinations of it. Okay, first thing I'm going to do, I'm going to take all 3 chlorines of relative mass of 35. Okay, all 3 of 35. One combination successfully created. Other combination I can think of, I will take all with the mass of 37. Okay, that's another good combination. 37, 37, and 37. I've successfully created 2 different combinations. Now, can I think of a third combination of, because I need 3 chlorines, okay? 1, 2, and 3. In first, I took all 3 of the same. In second, I also took all 3 of same. Now, what I can do, I can take 2 chlorines of 35, okay, 2 chlorines of 35 and 1 chlorine of 37. Don't you think that's going to work for me? That's also a combination. So I've created 3 different combinations. Can you create a fourth one? I can create a fourth one. What if I take 2 of 37, okay, 2 of 37, 37, 37, and 1 of 35, okay? I created a fourth combination. So how many different masses I can make? I can make 4 different masses, okay? Because I used 4 different combinations. In first, I used all 35. In second, what I did, I took all 37. In third, what I did, I took all 235 and 137. And in the last one, I took 237 and 135. And I successfully created 4 different combinations of this thing, okay? So that is what you had to do. I know these MCQs are tricky, but just stick to your basics, okay? Which statements about substances at room temperature and pressure is correct? Okay, we have W, we have X, we have Y, we have Z. Okay, W, okay, let's figure out first what is W. Okay, what is W? Can any one of you tell me? It's an alloy. Why is it an alloy? I can see different sized atoms arranged in layers. And in an alloy, because of these different sized atoms that are arranged in layers, the layers are unable to slip and slide over each other. It's difficult for the layers to slide. That is why alloys are harder. Okay, that is why alloys are harder. Try to think it like, for example, you have different balls. Okay, you have different balls and you're trying to slide the balls. If the balls are of the same size, they're easily going to slide. But if you have different, just try to think it, the balls are compacted in a small box. If you have different sizes of balls, the balls are not going to slide over each other easily because of these different sized atoms. So this is an alloy. Okay, this is lithium chloride, and you should know lithium chloride is a ionic compound. I guess no argument in this. Negative ion, positive ion, ionic compound. Y is going to be definitely diamond. Many people do not think about it, that Y cannot be its silicon dioxide, because silicon dioxide also has a similar structure. Why? Because try to look, all atoms are black, all are of the same shape, same size, meaning all are carbon atoms. So it has to be diamond, because diamond is purely made up of all carbon atoms, okay? So it has to be diamond. It cannot be silicon IV oxide. Why? Because otherwise you'd have 2 different type of atoms, silicon atoms and oxide atoms, okay? Not oxide, oxygen and silicon atoms, okay? So you can have different size, but this is surely diamond, okay? And this is your very own ethanol, okay? Ethanol, okay? And alcohol, 2 carbons. Okay, let's read. W and X conduct electricity. We have W, we have X. They conduct electricity. I must say that W conducts because alloys are good conductors of electricity. Why? Because they are made up of metals. And X would conduct, but not in solid state, in a liquid state. Okay, in a liquid state. So let's just leave it for the time, because the examiner is not specified either it's solid or liquid. Leave it. Let's read the other options. W and Y are elements. No, this is not element. Y is an element. Y is carbon, but W is an alloy. Alloys are mixtures of elements. So cross X and Z dissolve in water. Okay, what's X? X is an ionic compound. Ionic compounds dissolve, and Z is an alcohol, and alcohols also dissolve in water. So the option that's going to be correct is going to be C. Okay, so that's going to be correct. And now we know that W and X conduct electricity, but over here X is in solid state. So in solid state, X is not going to conduct, but when X is dissolved in water or molten, it's going to. But right now in the picture, it's in a solid state, so it will not conduct, okay? And Y and Z have low melting points. Y and Z have low. Y is diamond. Okay, diamond has a low melting point. Very good. That's in addition to my information. Obviously, it's not going to have. It has a melting point that's above 3000 degrees Celsius. So that much strong ionic covalent bonds are present in diamond. Okay, these lines are covalent bonds that are very strong. Above 3000 degrees Celsius, it's extremely hard, used in cutting tools. Okay, and Y, what is Y? Okay, this is Y, and what is Z? Okay, this might have a low, but diamond has very high. Okay, 26. Aqueous calcium hydroxide is an alkali neutralized by, this is a very good question. Okay, calcium hydroxide is an alkali neutralized by dilute nitric acid to produce calcium nitrate and water. What is the Ionic equation for the reaction? Many of you might be thinking that now we have to write calcium hydroxide, we have to neutralize it. Just think about one thing, that's a neutralization reaction, and the Ionic equation for a neutralization reaction is just OH negative plus H plus forming H2O. So that's simple, that's easy, it's going to be option D. You just don't have to look at all this because they're asking for an Ionic equation. Okay, question number 27. How many tons of aluminum oxide Al2O3 are required to produce 27 tons of aluminum? A very beautiful question again. Many people, what are going to do, not write the equation, going to spoil their paper by not writing equation. You have to write the equations of everything. So how many tons of aluminum oxide are required to produce 27 tons of aluminum? You have to write the equation. You have aluminum oxide Al2O3. Without equation you cannot do it, and you have to produce aluminum plus O2. Okay, so that's what you have to do. So first of all A3 here, A2 here, and A4 here. Okay, if you don't write the equation, how can on earth you're going to figure out these moles? Okay, many people don't write the equations. You can never figure out these moles if you don't write the equations. So now you just have to do simple stoichiometry. You have to figure out that 2 moles of aluminum oxide going to form 4 moles of aluminum. Just figure out the mass of 2 moles of aluminum oxide. So it is going to be, okay, 2 times 27. Okay, this is the basic that you must know before your exam, plus 3 times 16. Okay, what I'm doing, I'm just figuring out the mass of this entire thing. Okay, so 2 times 27 plus 3 times 16, 2 times 27 plus 3 times 16 times 2, that is 204. So 204 is the entire mass of this 2 times of this aluminum oxide. And now I have to just do 4 times 27. What is 27? The mass number of aluminum. So 4 times 27. 4 times 27. If you haven't created the equation for this reaction, you are already gone. 108. So 24 grams of aluminum oxide produces 108 grams of aluminum. 24 grams of aluminum oxide producing 108 grams of aluminum. Okay, you can take it in tons as well. Okay, this can be in tons, kilograms, anything. So now I take it in tons because I have in tons. So I will just think that this is 204 tons produce 108 tons. If you take in grams, so 204 grams produce 108 grams. If you take it in kilograms, so 204 kilograms will produce 108 kilograms. So now my 27 tons, 27 tons of aluminum oxide will produce X tons of aluminum. So it's simple, cross multiply 27 times 108 divided by 204 times 27 divided by 204, that gives me a 14.29. Okay, we have no option of 14.29. Okay, I'm sure I must have done something wrong. Okay, 108 multiplied by 27. Let's do it again. 108 multiplied by 27 divided by 204, and that's again giving me something wrong. I must have done something wrong with the 2 3s are 6. Okay, 3 2s are 6. Let's figure it out. I guess I've just taken out the wrong mass of this thing. Okay, my options are telling me, okay, I have to take 27 plus 27. Okay, let's do it again. 27 plus 27 plus 16 plus 16 plus 16, 102 times 2, that's 204. Okay, I have, how many tons of aluminum oxide are required to produce 27? Oh, I just, look what I did. Okay, that's all of you what can do. Okay, look what I just did. This is my aluminum oxide. Okay, this is my Al2O3. I thought 27 tons of aluminum oxide. What is in the question? 27 tons of aluminum. So I had to write 27 under aluminum column. I wrote it under aluminum oxide, and now this is my X. Okay, this is my X. So okay, any one of you can do this blunder. Okay, be careful what's in the question. I thought it was aluminum oxide. How many 27 tons of aluminum oxide would produce how many tons of aluminum? But it was how 27 tons of aluminum would be produced by how many tons of aluminum oxide? Oh, okay, 204 times 27. 204 times 27 divided by 108, that's 51 tons. Okay, 51 tons, which is option B. Okay, I know this was difficult, but you just had to make an equation before starting the question. Okay, next question. Compound X is sodium iodide, NaI. Compound Y is methyl methanoate, okay, HCO2, CH3. Okay, we simple have an ionic compound, sodium iodide. We have a ester, which is methyl methanoate. At room temperature and pressure, dash is a solid. What do you guys think? Are esters solid at room temperature? Okay, do it before I do. No, they are not. Esters are liquid. So it's going to be only X. X is the Ni. Ionic compounds are obviously solid. Okay. In aqueous solution, 2 conducts electricity. What do you guys think? In aqueous solution, ionic compounds for sure conduct electricity. But what do you guys think about the ester? Are esters going to conduct electricity? No, they're not going to conduct electricity. Why? Because esters are organic compounds, okay? They don't ionize in aqueous solution. So it's going to be only X. Only X and only X, which makes option D to be the correct one. Okay, moving on. Okay, another nice question. I'd love if you guys solve it before me. For the forward reaction, okay, for the forward reaction of a reversible reaction, the enthalpy change for the reaction is this, and the activation energy is this. What is the activation energy of the reverse reaction? Okay, can any one of you tell me what is the activation energy of the reverse reaction? Okay. Let's draw an energy profile diagram to better understand this question. We have this reaction. We know that the enthalpy change is negative 150. So our reactants are going to be above. These are my reactants. My products are going to be below. These are my products, okay? And from the reactants to the products, I make an arrow like this. Okay, from the reactants to the products like here is going to be my enthalpy change, which is a negative 50, okay? The value is 50. And now my activation energy for my exothermic reaction is going to be from the reactants to the top of this energy hump. You call this thing an energy hump, okay? And this is my 60 kilojoules per mole. What is the activation energy of the reverse reaction? Oh, this is a kind of an A-levels kind of style question, okay? What do you guys think? What do you guys think? Firstly, activation energy can never be negative. So I cross out this and this, okay? Activation energy cannot be negative. Boom, boom, cross. Out of these two, what is correct? Always remember that for your exothermic, it's from the bottom. For your exothermic, it's from the reactants to the energy hump, and for an endothermic, because look, if the forward reaction is exothermic, okay, if the forward reaction is exothermic, the backward is definitely going to be endothermic, okay? If the forward reaction is exothermic, the backward is going to be an endothermic reaction, okay? So if this is exo, the reverse is going to be endo. And for endothermic, I have it from the bottom to the top of energy hump, okay? From the bottom to the top of energy hump. This is going to be my activation energy, which is 50 plus 60, okay? This is, and I again say this is kind of A-level style. It's going to be 50 plus 60, which comes out to be 110 kilojoules per mole, okay? I know it was difficult, but you just had to realize a bit of things. If forward is exo, backward is endo. For endo, it's from the bottom to the top, and it can never be negative. Moving on. Okay, another very nice question. Let's solve it. Nitrogen dioxide is a dark brown gas that decomposes as shown in the equation, okay? The diagram shows a glass flask containing a mixture of 3 gases. The mixture is pale brown, okay? Mixture, it's pale brown. This is dark brown, this is colorless. Okay, if the equilibrium move towards the forward side, it's going to turn colorless or it's going to turn pale brown. ठीक है, अभी initially brown है, but colorless तो obviously एकदम से brown से नहीं होएगा ना, वो pale होएगा ना. And if the equilibrium is going to move backwards, it's going to turn darker in color. Okay, more oxygen is forced into the flask. Okay, I increase my oxygen. What is equilibrium going to do? Equilibrium always tries to balance out whatever I do. If I increase the amount of oxygen, equilibrium will decrease it. And to decrease it, it's going to move towards the backward side, okay? Which color change is seen in the mixture? Okay, when I increase the amount of oxygen, to decrease it, equilibrium is going to shift backwards. And when equilibrium shifts backwards, it's going to turn darker brown, okay? It becomes darker brown. Option A is going to be correct. Okay. Concentrated hydrochloric acid is oxidized by manganese oxide. Okay, what are the two products of this reaction? Oh, that's really interesting. Okay, concentrated hydrochloric acid is oxidized by manganese oxide, MnO2. And what are the two products of this reaction? Can you guys figure out the oxidation number of manganese right here? Okay, I can. I know my oxygen is A2 negative, and I have 2 oxygen, so it's going to be a 4 negative. And to balance out a 4 negative, my manganese must be a positive 4. Now, concentrated HCl is oxidized. Okay, HCl is oxidized. Oxidized means that there must be a loss of electrons. Okay, loss of electrons. Okay, so in HCl, chlorine was a negative 1 and hydrogen was a plus 1. Because there's a loss of electrons, so now chlorine has to go from negative 1 to 0. It has to be oxidized because HCl is oxidized. So it has to oxidize. It had to go from plus 1 to 0. So chlorine has to be in elemental state, which is 0. So either it can be this or this. Now if HCl is oxidized by manganese oxide, then manganese oxide must be reduced. Because if HCl, one thing is oxidized, other has to be reduced. So manganese oxide has to be reduced. Okay, this manganese oxide, it has to be reduced. How can I reduce this? It has a charge of plus 4. Reduction means a decrease in oxidation number. So from plus 4, it cannot go to plus 6. That oxidation from plus 4, it has to go to plus 2. That is reduction. From plus 4 to plus 2. So it has to be plus 2, not plus 6, because that will be oxidation. I know it was challenging, but you just have to understand the basics. What is oxidation? It is loss. What is reduction? It is gain. Okay, and you're going to figure it out. Next MCQ. Okay. This one is 31, so this has to be a 32 MCQ. Okay. Another very beautiful MCQ. The table gives some information about 4 redox reactions. Okay, which row gives correct information about what is oxidized and the evidence that it is oxidation? Okay, first I would go to evidence. I know oxidation is loss of electrons or gain of hydrogen. Copper oxide has given oxygen to carbon. So if copper oxide has given oxygen to carbon, so it has lost oxygen. Okay, if I give my money to someone else, I have lost my money. So if it has lost its money, how can it be oxidized? It has to be reduced. It has lost oxygen. So this is incorrect. Okay, next. It is oxidation. Sodium is oxidized because it lost an electron. The evidence is correct, so we're going to take it. Nitrogen has been oxidized because it has gained hydrogen. Okay, it has gained hydrogen. Let's check out the oxidation number. Over here it was a 0. Over here it's a 3 negative. Okay, so that's definitely reduction. That is not oxidation, so that's incorrect. And oxidation is, remember, oxidation is not gain of hydrogen, it's loss of hydrogen. I'm going to just write it over here. Oxidation is loss of hydrogen. Okay, oxidation is always loss of hydrogen. That is incorrect. Okay, zinc has gained. Gain is never oxidation, it's reduction. So it's option B. But if you have to check the equation as well, let's check out the equation. Over here, sodium was a 0, okay? And over here, sodium is a plus 1. So from 0 to plus 1, increase in oxidation number and a loss of an electron, which makes option B to be the correct one. Okay, which method should be used to make a pure sample of potassium chloride? Okay, now if anyone of you can tell me this, I'd be really impressed by your skills if you're able to figure out which method are you going to use. All methods are correct. Not even a single method is wrong. All methods are correct. But what are we going to use? What do you guys think? Try to think about it. Potassium chloride. Potassium is extremely reactive. And when we are using extremely reactive metals like potassium, sodium, we never put them just by, prepare them by this. What we do is we do titration. To prepare a salt of reactive metal like potassium or sodium, we'd always use titration. So I didn't even read this, I just read titrating and I underlined this option. Okay. Oh, this one is a really, really, really good MCQ. Let's try this. Element Y in period 3 of the periodic table. Try this yourself as well. Okay. It forms a chloride that is liquid at RTP. Okay, first of all, element Y is in period 3, and secondly, it forms a chloride that is liquid at RTP. Okay. Which row shows the correct information about group number and the nature of the oxide of element Y? Firstly, it has to be in period 3, so group number can be anything out of this, and it forms a chloride that is liquid at room temperature. If it is in group 1 or 2, I say sodium, for instance. Can a sodium chloride be liquid at room temperature? And if I take group 2, for example, magnesium chloride, MgCl2, can it be a liquid at room temperature? Never. These are ionic compounds. The chlorides of group 1 and 2 are going to be ionic compounds. They're not going to be liquids, but solids at room temperature. So boom, boom, cross. Okay. Option C and D. Okay, now either it can be group 4 or group 5. I guess this is 6 or group 6. And group 4, it's written amphoteric, and group 6, it's written acidic. I know that my group 6 oxide, because it's a non-metal, are going to be acidic. So I'm going to select option D. Okay, and that's simple. Now you might think group 4 oxide can be an amphoteric oxide, but okay, let's check it out in the periodic table. We must have a periodic table over here. Let's check out what's in period 3. Okay, this is period 1, period 2, period 3. If I go across my period 3 and group 4, okay, just think about this as your group 4 and this about as your group 6. Okay, in group 4, in period 3, I have silicon, and in group 6, in period 3, I have my sulfur. So I know that silicon oxide is not amphoteric because I have not read about it. The only two amphoteric oxides in my syllabus are zinc oxide and aluminum oxide. So I don't know about silicon oxide if it's amphoteric or not, but for sulfur oxide, I know for sure it's going to be acidic. Why? Because it's a non-metallic oxide, and I know that all the non-metallic oxides are acidic oxides. So option D is going to be correct. Okay, now this one is a really, really good MCQ. It's going to test your physics concepts as well with your chemistry concept. If you're able to do it, then you're going really well. Okay, the diagram shows the experiment to determine the percentage of oxygen in air. You know, oxygen is 21% in air. Which diagram shows the correct level after the candle stops burning? Okay, tell me, what's going to be the correct level? What do you guys think? Okay, this involves a bit of physics. Try to think it like this, if you know physics, that this is over here. Okay, over these two surfaces, what's acting? Atmosphere. Okay, over these two surfaces, the atmosphere is pressing the water in. And over here, you have air. Okay. And over here, air is pressing the water in. So right now, the water level is same for both. This means over here you have air that is pushing downwards, and over here you have atmosphere that is pushing downwards by equal force. So the level of water is equal. Now 21% is oxygen. Now some of the oxygen in this bell jar is going to be used up. So now the air over here is less. And the push downwards, just think about it, air is pushing downwards. Okay, air is pushing downwards, and now some of the air has been used up, so there is less air. So the push of air downwards is going to be less, so the water level is going to rise. Because oxygen in the air has been used up. So now the air is pushing less harder, and because the air is pushing less harder downwards, the water level is going to rise. So it's going to be option C. I hope you understood this. This was easy. Okay, but apply, there was a little bit of physics in it, that because the pressure is going to decrease inside, the water level is going to move up, because now the air is pressing on the water with less force because the oxygen in the air has been used up. Okay, so that was the main concept, and option C the correct option. Okay, two statements are given. Statement 1, the percentage of carbon by mass is greater in methane than butane. No, remember, methane, butane, both alkanes. In all alkanes, the percentage by mass of carbon is going to be the same. Okay, you might not get this, but we're talking about percentage by mass, okay? And when we talk about percentage by mass, it's basically the whole number ratio. It's going to be the whole number ratio. For instance, I take C2 and H6, and I take C4 and H10. You might think these are both two alkanes, okay? This is ethane and this is butane. Calculate it by yourself, the percentage by mass of carbon, okay? Calculate it yourself, okay? You're going to find that both of them have equal percentage by mass because both of them are alkanes. So statement 1 is correct. Statement 2 is butane is one of the two isomers with the molecular formula of C4H10. Butane is one of the two isomers with the molecular formula of C4H10. Okay. Is one of the two isomers with the molecular formula of C4H10. Let's draw it. C4 and yeah. It is correct. Butane is one of the two isomers. You can make two isomers with the formula of C4H10. Okay. What you can do is you can draw it like this, all carbons in one chain, or what you're going to do is draw 3 carbons in one chain and one like this. You can do a branching. And this is butane and this is 2-methyl propane. Okay, this is 2-methyl propane. Why 2-methyl propane? Because on the second carbon you have a methyl group, and that's the long chain is the propane chain. So that's a 2-methyl propane. So butane is one of the isomers, is one of the two isomers. Yeah, that's correct. So both statement 1 and 2 are correct. The percentage by mass is great. Oh no, that's incorrect. Sorry. One is incorrect. It's not greater, it's equal. The percentage by mass is greater in methane than in butane. No, both have equal percentage by mass, so that's going to be incorrect. Okay, I thought it was written equal. So statement 2 is only correct. Okay, next one. Compound need exactly 9 moles of oxygen for complete combustion. Okay, how many compounds need exactly 9 moles of oxygen for complete combustion? 1 mole of each of the compounds shown is completely combusted. Okay, 1 mole of this is combusted, and how many compounds need exactly 9 moles of oxygen? We have to write combustion equations. Okay, it cannot be done without the combustion equations. Let's you should never be afraid of doing hard work because that's going to pay off. Let's do hard work. C5H12 and O plus O2 gonna give me carbon dioxide and water. I have to balance it out because it's a 5 here, I put a 5 here. Because it's 12, I put a 6 here. How many oxygen I get? 5 2s are 10. 10 plus 6, that's going to be 16. So I need 8, not 8, because it's 16 and 1 oxygen is here. So 16 minus 1, I need 15. And I cannot write a 15 here, so I write a 15 upon 2. Okay, so I need 15 upon 2 is a 7.5. So I need 7.5 moles over here. So definitely not this one. Okay, I hope you guys understand what I'm doing. I'm just writing simple combustion equations for 1 mole. It's important that over here is 1. Okay, I cannot make it 2. Okay, so that is important because it's written exactly 9 moles of oxygen for the complete combustion. Okay, 1 mole of each of the compounds shown is completely combusted. So only 1 mole I have to write. So it has to be 1. You might think that I can add a 2 over here and then I can multiply this by 2 as well to make it a whole number, but that's going to be incorrect because I'm writing for 1 mole. Okay, next equation, moving on, is going to be this. C6H12 plus O2 give me a carbon dioxide and water. Okay, C6, so 6, H12, so 6. 6 2 times is going to be 12 plus 6, that gives me 18, so 9 moles. Okay, so this is definitely going to use 9 moles. So I circulate with red. Okay, next C6H14. Okay, C6H14. C6, now let's cross it out and write H14. Cross this out. Okay, cross everything else out. And now do our equation again. Okay, this is CO2. I have C6H14. I have to do a 6 over here because I have 14. I have to do a 7 over here. That's 6 2 times 12 plus 7. I guess that's going to give me 12, 13, 14, 15, 16, 17, 18, 19. 19. I have 19. So I need a 9.5 moles over here. Definitely this is incorrect. Okay. C6H14NO. Okay, C6H14NO. I just add an O over here, and I kind of erase this 9.5 from here. Okay, now I do it again. Okay, C6 over 6 over here, H14, so a 7 over here, 7 2 times 14, that give me 6 2 times 12 plus simply 7, just let's do it, 12 plus 7. Okay, it's a 19. I need 19 moles. I need 19 oxygen. 1 oxygen I already have over here, so 19 minus 1, that's going to give me an 18. So I need 18 from here, so a 9 over here, so definitely this one as well. So it's option this and this. They are going to require 9 moles. So 2 compounds. It's going to be B. I hope you get it. Moving on, which compounds are in the same homologous series? Okay, if you're good at chemistry, just try to solve this one. Which compounds are in the same homologous series? What do you guys think? Which compounds are going to be in the same homologous series? Okay, what I think is that I need to first let me just try to see it myself and figure out. Okay, CH3, CH2, CH3. Some people can do it by looking as well. If you've done enough past papers, you're going to realize that you can do it by looking. Okay, over here that's an alkene, so definitely not option D, because this shifted at an alkene. Okay, now this one CH3, CH, okay, OH, and then CH3, okay, that's an alcohol. Okay, CH3, CH2, CH2OH, that's again an alcohol. Okay, CH3, CH2, COOH, that's an acid. We need all alcohols or all acids. Okay, now this one CH2, okay, then CH, and then okay, CH, and then CH3. Okay, that means over here there's a double bond present, so that's an alkene. Now let's move over here. Over here there's a double bond present. I can just tell it by looking that the valency of carbon is not completed, so a double bond definitely present. And over here we have a double bond here, so all these three are alkenes. If you cannot figure it out, no worries. Okay, no worries. What you have to do, you just have to draw the formulas. Okay, just draw them. Okay, you're gonna figure it out. This is an alkane. Over here this is an alkene, so definitely not A as well. It's B. And if you cannot tell just by looking, no worries, just draw all the formulas together. Draw it like this is C, H, H. Draw it like this, and you're gonna figure it out. Okay, okay, another very good question. Some metals and the compounds in their ores are shown. Okay, metals and the compounds. So which type of reaction occurs in the extraction of each of these metals from its ore? Decomposition by heat, electrolysis, precipitation, reduction. Okay, before you should select the correct option, I'd like to tell you one thing. Okay, I'd like to help you by telling you one thing. What is the oxidation state of aluminum over here? 0. What is oxidation state of aluminum over here? 3 plus. Over here calcium is 0. Over here calcium is 2 plus. Lead is 0. Lead is 2 plus. Sodium 0. 1 plus. Iron over here is 0. Over here it's 3 plus. Over here magnesium is 0. Over here magnesium is 2 plus. What is common you are finding in all of them? What's happening? From 0 to 3 plus, increase in oxidation number. From 0 to 2 plus, increase in oxidation number. From 0 to 2 plus, increase in oxidation number. From 0 to 1 plus, increase. All of them are increasing their oxidation numbers. Okay, so over here in the ore, the oxidation number is 3 plus. Okay, and when it goes into a metal, the oxidation number basically decreases. Okay, it decreases because we're talking about what type of reaction occurs when the extraction of each of these metals from its ore. So in the ore it has 3 plus, and when it's aluminum it's 0. So what's happening over here? Don't you think that this from 3 plus going to 0, because in the ore you are 3 plus, but when you form a metal you go to 0. Okay, you're going to 0 from 3 plus. What is this? A decrease in oxidation number, so that is reduction. So what's happening in all of them is reduction. So all of them are being reduced. So it's going to be what type of reaction occurs? It's going to be a reduction reaction. Precipitation is impossible. Okay, these are reactive metals. They don't form insoluble salts. You use precipitation for insoluble. Electrolysis, it's not a type of reaction. Electrolysis is a process. Decomposition by heat is a process, not a type of reaction. So it is reduction. I know this MCQ was tricky, so just try to grasp the concept that what's happening when it's going from the ore to the metal. Okay, in which substance does the nitrogen atom have the same oxidation number as a nitrogen atom in this? Okay, assume the following oxidation numbers for the elements in these compounds, H plus 1, F negative 1, O 2 negative. Okay, I guess we have to first figure out the oxidation number of nitrogen over here. Try to think about this. Oxygen is a 2 negative, okay? 2 negative is 1 oxygen. We have 2 oxygen, so it's going to be a 4 negative. And H is a plus 1. So nitrogen, to balance out a 4 negative, we already have plus 1. So how many more do we need? We need a 3 plus. So nitrogen over here is a 3 plus, okay? And now I have to find somewhere where nitrogen is 3 plus. Over here, fluorine is 1 negative, okay? They have told us. And we have 3 fluorine, so it's going to be a 3 negative. To balance out a 3 negative, I need a 3 plus. Option A is going to be correct, because over here as well nitrogen is 3 plus, and over here as well nitrogen is 3 plus. Let's figure it out over here. Hydrogen, okay, hydrogen, they told us that we have to take hydrogen as plus 1. Okay, hydrogen has to be plus 1. Okay, we have 4 hydrogens, okay, so we have to take it as 4 plus, okay, 4 plus. And we have to, because there's a plus 1 charge, so we disinclude 1 hydrogen, because overall charge is plus 1. So we have to take 3 plus, okay? And to balance out 3 plus, we need a 3 negative. So that's incorrect. We need a 3 plus on nitrogen. Over here, that's so easy. Nitrogen is 2 plus, because oxygen is 2 negative. To balance out 2 negative, you need a 2 plus. That's again incorrect. So option A is the correct one. Okay. A solution of sodium carbonate is added to tap water. A white precipitate forms. Which ion is present in tap water that causes a precipitate to form? Sodium carbonate. Okay. Na2CO3. Which carbonate is going to form? That's going to be insoluble. Can a carbonate be formed by chloride? No. Chloride carbonate can not form. Magnesium carbonate? Yes. Magnesium carbonate is going to form a white PPT. What about potassium? If this carbonate, a solution of sodium carbonate is added to tap water, ना, अगर tap water में potassium है, तो potassium carbonate is going to be formed, and potassium carbonate is soluble. All group 1 carbonates are soluble, and ammonium carbonates are soluble. And sulfate, okay, sulfate might combine with sodium. So sodium sulfate soluble, sodium chloride soluble. So only one insoluble salt is being formed, that's magnesium carbonate. So magnesium ions are present in tap water that basically combine with my carbonate ions to form magnesium carbonate. Okay, and again, very interesting question. Try to solve it before I do. A lovely question, let's solve it. Aqueous bromine is in an equilibrium mixture, okay? Aqueous bromine is an equilibrium mixture, okay? Bromine, water, O, B are negative ions, B are negative ions, 2H plus ions, okay. Aqueous bromine is orange in color. Aqueous bromine is orange in color. So this is aqueous bromine, that is orange in color. Bromine, not bromide, this is bromide, okay? Don't take this. This is orange, okay? This is orange in color. The species on the right hand side of the equation are colorless, okay? This all thing are colorless, okay? So now I know if my equilibrium move towards the right, it's going to become lighter orange, okay? It's going to become colorless. Towards colorless, it's going to become pale orange. If it moves towards the right, it's going to become dark orange, okay? Changes are made to 3 separate portions of the equilibrium mixture, which row shows the color of the mixture changes when a small amount of each substance is added. Adding sulfuric acid. Oh, you might think it's so difficult. What are we going to do? Because if you add sulfuric acid, there's nothing as sulfuric acid over here. What are you guys going to do? I just want to test your chemistry. If you add sulfuric acid, there's no sulfuric acid in this entire thing. So what are you going to do? Sulfuric acid, try to think about it as like this. H2SO4 gives H plus ions. If I add sulfuric acid, my H plus ions are going to increase. And when my H plus ions are going to increase, to decrease it, equilibrium is going to move backward. And when equilibrium moves backward, it's going to become darker orange. So adding solid, okay, that's going to become darker orange. That's correct. Okay, adding solid sodium bromide. Okay, I'll come to this later. First, let's discuss adding water, because that's simple, I guess. If you add water, simply, if you increase water, equilibrium will try to decrease it, will move towards this side, and it has to become colorless. So it's going to become pale orange, okay? You add water, equilibrium will shift towards the forward side to decrease water. So it's going to become pale orange, okay? So a paler orange and a paler orange. So definitely for this one, we have to choose this option, which is B. because that's the only correct option that's possible. So now you already know that the correct option is B. So now you don't have to even check for adding solid sodium bromide, but for sodium bromide, it's becoming darker orange, meaning equilibrium is shifting backwards. Why? Just think about it. When you add solid sodium bromide, think about it like this, okay? Solid sodium bromide. This is an ionic compound. And when you add ionic compound to this, because there's water in it, it's going to dissolve. And when this dissolves in water, what's going to become? It's going to form sodium ions. Sodium ions are useless over here because there's no work, and bromide ions. And when your bromide ions are going to form, it's going to increase the amount of bromide ions on this side. And when there are more bromide ions on this side, equilibrium is going to shift towards this side to decrease them. And it's going to become darker orange. Okay? I know this is confusing. No worries. Just try to understand the concept. And that's all for this question. Okay? This question. Again, an interesting question we have. A student plans to investigate how the rate of the reaction changes when hydrochloric acid and calcium carbonate react. Calcium carbonate, hydrochloric acid forming this. Okay. Rate of the reaction is being measured. 3 methods are described. Okay. 1, 2, and 3. Which methods can be used to measure how the rate of the reaction changes? Okay. Whenever you're measuring the rate of the reaction and you're measuring the change, what do you need? Okay. For example, I'm measuring rate. So what I'm going to do is I'm going to make a table. Okay. What kind of information I'm going to collect? I'm going to collect the volume of my gas after fixed time interval. For example, I'm going to collect after 5 minutes, then after 10 minutes, then after 15 minutes. And I'm going to check for example, over here it was 50 cm cube, over here it was 70, over here it was 75. So that's how I'm going to check my rate of reaction. Okay. So now let's check which of this, thing fulfills my condition that I have to check the rate. Record the mass of the flask and the contents every 30 seconds for 5 minutes. Okay, that's correct. After every 30 seconds, if I check for 5 minutes, I'm going to check how much mass has been decreased, because my carbon dioxide gas is being formed, and when my carbon dioxide gas stops forming, I know the reaction has stopped. So the contents on the balance are going to stop changing. Okay, so that is correct. Okay, now option 2. Measure and record the volume of the gas in the gas range after 30 seconds. If I only check it once after 30 seconds, can I measure the rate? I have to check it for at least 5 minutes or 2 minutes or 3 minutes. The method is correct. The way it is checking, it's correct. If I just measure the volume of the gas being formed, I can easily measure the rate. But the thing is that it is only measuring after 30 seconds, not for 5 minutes. Okay? So this is incorrect, because that is not how I can measure the change in rate. Okay, so option 2 is incorrect. Now option 3. So option 3 says that count and record the total number of bubbles of gas in the water for every 30 seconds for 5 minutes. You might think it's incorrect, but that's also correct. If you count the number of bubbles, you can know that how much of your gas is being produced, and you're doing it for 5 minutes after every 30 seconds. So you're going to know the change. Okay, first, for the first 30 seconds, I counted 10 bubbles. But the next 30 seconds, after next 30 seconds, for example, after 60 seconds, I counted 2 bubbles only. So that's going to tell me how the rate is changing. So option 3 is also correct, because of this 5 minutes, because I'm doing it after every 5 minutes. But over here, I only did it for 30 seconds and I stopped. So that's incorrect. So it's going to be 1 and 3, which is option C. I hope you get it. Okay. Octane is a hydrocarbon. Okay, when octane is mixed with an excess of oxygen, no change takes place unless energy is supplied. What do you guys think? What kind of reaction is this? You need energy. Why do you need energy? To provide the activation energy. That's why no reaction takes place unless you don't provide it with the activation energy, because activation energy is the minimum amount of energy that the reactant particles must have in order to react. Okay. If the energy is supplied in the form of heat or an electric spark, a change takes place. The products of this change include carbon dioxide. Okay, we know carbon dioxide and water are going to form and octane is going to combust. Okay, which part of the description shows it's a chemical change? Okay, if you if you have your exam tomorrow, I'd like if you solve this question yourself, because I am sure about the fact, because chemical changes and physical changes are newly added to the syllabus. Examiner is eager to test these changes, and I've read into the 3 examiner reports where the examiner says that the candidates are not very good at their knowledge about chemical and physical changes. So try it yourself. Tell me what's the correct answer. Okay, you have a few seconds to just decide the answer. Decide it yourself. And now I tell the correct one. The correct answer is going to be, in a chemical change, which part of the description shows that the chemical change? Chemical change means new product formed. New product formed. Bonds broken. My previous bonds being broken and my new product being formed is going to be a chemical change. So octane is a hydrocarbon, nothing to do with bonds broken with a new product being formed. No change takes place unless energy is supplied. That's about the activation energy. Activation energy has nothing to do with the chemical change. Change takes place quickly. Physical change can also be quickly. You can quickly supply heat to melt a substance. That's also going to be, heat is going to be supplied in a physical change, and it's going to take place quickly. Carbon dioxide is produced, a new product is being made. This is what tells you that it is a chemical change, because in a chemical change a new product is going to be formed, and over here you're making a new product, that's carbon dioxide, so it's going to be a chemical change. Okay, I hope you get it. Moving on to this MCQ, another of my favorites MCQ. Okay, under certain conditions, nitrogen reacts with oxygen to form nitrogen oxide. Okay, why is it not nitrogen dioxide? Dioxide is when you have two oxygens. Over here you have two nitrogens. So please don't say this is nitrogen dioxide. Okay, no worries, because that's not what is being tested. What's being tested is this. Okay, the reaction pathway diagram shown. I know that my reactants are below. Okay, my reactants are below, my products are at the top. So this is going to be an endothermic reaction. Okay, this is the activation energy EA. This is from the reactants to the products is my enthalpy change, which is delta H. What is the activation energy for the reverse reaction? Okay, that is where the joy comes in. What is the activation energy for the reverse reaction? Okay, recently examiner has been very interested in reverse reaction rather than the forward reactions. By giving the details for the forward reaction, examiner expects you to get the activation energy for the reverse reaction. Okay, the forward reaction is endo, so backward reaction is going to be exo. Okay, for the exothermic reaction, firstly, activation energy can never be negative. Cross. Okay, for an exothermic reaction, the activation energy is from this level, okay, from this level to the top of energy hump. Okay, so this is your activation energy. Okay, I hope you get it. It's going to be from this level, this line to the top of your energy hump till here. So how to get this? Okay, you need just this much of the line. Okay, you just need this much of the line. This part you need. This is going to be your activation energy for the reverse reaction, which is exothermic. So out of this total line, okay, this is the total line. If you subtract this line, okay, if you subtract this line, you're going to get this line. Okay, I'm trying to repeat this again. I know it's difficult to understand, but first understanding is that backward is going to be exo. Second understanding is that out of this total line, if I subtract out this line, okay, till here, I get this line, and this is what I need. So out of my 447, I need to subtract 164. Okay, so 447 minus 164. Okay, 447 minus 164, that's going to give me 283. So it's 283. All these MCQs that we are practicing today, please learn the concepts which I am explaining in them, because they might be tested tomorrow, and these are the most difficult ones I could find for you guys to practice. Okay. The complete combustion of 20 cm cube of a gaseous alkane requires 13 cm cube of oxygen. Both volumes are measured at RTP. What could be the identity of X? Oh, that's such an interesting question. Butane, ethane, methane, propane, what can it be? Okay, I'm going to help you by telling you one thing. Always remember that the volume ratio of gases equal to their mole ratio. Okay, so if I have butane, okay, butane, which is going to be C4 and H10, okay, and if I add in it oxygen, 20 and 30, 130. Okay, 20. Okay, if I just write it like 20 and 130, what's the simplest ratio of 20 and 130? If I cut the 0 divided by table of 10, I get 2:13. So it can simply be taken as 2 moles of this and 13 moles of this, because volume ratio can be taken as the mole ratio in the equation. Okay, is going to form carbon dioxide and water. So, okay, both are measured. What could be the identity of X? Let's balance it out to check, do we get a 13 over here? Okay, so if I balance it out, 2 4s are 8. So 8 over here, and 2 5 times 2 10 times 20, so 8 20 over here, not at 20 at 10 over here because I have to take half, so 8 and 10. That's going to make me 8 2 times 16, and 16 plus 10 is going to make it 160. Not 160, I'm so sorry, what am I doing? 16 plus 10 is going to make it 26, and 2 multiplied by 13 gives me 26, है So that's correct. There's going to be a 13 over here, which makes option A, butane, to be correct. Let me check. 2 multiplied by 13 should give me 26. It gave me 26, so why do I have to work all this out when option A came out to be correct? So I hope you get it, that mole ratio and volume ratio are the same things, and you just had to balance it out to figure out was the 13 coming over here or not. Okay, this was easy. Moving on. Okay, germanium is in group IV. What is IV? IV means 4. Okay, of the periodic table, it has a proton number of 32. Okay, selenium is in group VI. VI means A6. Of the periodic table, it has a proton number of 34. That means that they are in the same period. How do I know in the same period? Because look, if this is my periodic table, they are arranged according to proton numbers. Okay, this is my group 4, this is my group 5, this is my group 6. Over here is my germanium, which is, for instance, I say GE. Over here is my selenium, which is SE. Okay, and this has a proton number of 34. So obviously whatever is over here is going to have 35, and selenium is 30. No, sorry, this was 32. Sorry. If this is 32, whatever is going to be here is going to have a proton number of 33, and whatever over here, which is selenium, is going to be 34. So that means it's across the same period. The period is same. Okay. What prediction can be made based on the positions of germanium on selenium in the periodic table? A germanium atom has 2 more valence electrons than a selenium atom. That's incorrect. Selenium has 6 valence electrons. Germanium has 4 valence electrons. So selenium has 2 more, not germanium. Okay, germanium forms a Ga3 plus ion, and selenium forms Se3 negative. Complete nonsense. Germanium cannot be a 3 plus. I don't know where did this came for. It has to be either a 4 plus or a 4 negative. Either it loses 4 or it gains 4 to complete 8. Okay, germanium has more metallic character than selenium. That's correct. Because the more you are on the left side of the periodic table, the more metallic you are. Because over here on the left side you have sodium, lithium. The more on the left, the more metallic. The more on the right, the more non-metallic you get. So selenium is more non-metallic. So germanium is more metallic. So it's going to be option C. Option D is germanium has similar properties to tellurium, and selenium has similar properties to tin. For this, you'd have to check out the periodic table. Okay, germanium and tellurium, and selenium and tin. Okay, let's check out the periodic table. Okay, for germanium to have similar properties to tellurium, it must be in the same group. Okay, in the group of germanium, I don't find any tellurium kind of thing. This is germanium. Okay, I don't find any tellurium over here, so that's incorrect. Germanium has similar properties to tin because they are in the same group. And selenium has similar properties to tellurium. Over there, they have reversed. They've made selenium with tin and germanium with tellurium. That's incorrect. Okay, so we are done with this thing. Now, I hope you get it. They just tried to confuse us with this. Which metal reacts with steam and can be extracted from its ore by reduction with carbon? Reacts with steam. So copper not going to react. Just learn your reactions good. Okay, copper not going to react. It has to react with steam and can be extracted from reduction with carbon. That means it has to be lower in the reactivity series than carbon. Carbon is here. It has to be below carbon. Magnesium is definitely above carbon. Calcium is above carbon. Only zinc is below carbon. And zinc also reacts with steam. Copper is also below carbon. But there is another option that it should react with steam. Copper does not react with steam. Okay. So, done. Okay. Solution X is colorless. Okay, a few drops of aqueous potassium iodide are added to a sample of X. No change is seen. Okay, a difficult MCQ, a really difficult MCQ that you're going to find. Solution X is colorless. Okay. A few drops of potassium iodide are added to sample of X and no change is seen. Okay, what you guys can conclude from this that no change is seen? Always remember that Ki is used to test for, okay, this is going to be a difficult concept to digest, but just try to follow what I'm going to tell you. Okay, Ki is used to test for oxidizing agents. Okay, this is used for, just learn what I'm telling, because tomorrow is the exam, you need to be proficient at this. This is used to test for oxidizing agent. Okay, and if it changes color, if I add, for instance, I add Fe something to it and it changes color, that means whatever I've added to it is an oxidizing agent. Okay, because Ki did not change color, that means solution X is not oxidizing agent. Okay, it's not an oxidizing agent. So X is an oxide. No, it cannot be oxidizing agent. If it was oxidizing agent, it would change color when added to Ki, because Ki is a reducing agent, and reducing agent and oxidizing agent react together to change color. They change color from colorless to brown. So if something added to Ki and it does not change color, that means it is not an oxidizing agent. So it is not an oxidizing agent. Okay, that is correct. Okay, first part we figured out. Okay, next part. Solution Y is also colorless. A few drops of solution Y are added to acidified potassium manganate. Solution are added to sample Y. The color of potassium manganate disappears, meaning it changes from purple to colorless. And whenever potassium manganate changes color from purple to colorless, that means that, I know this is confusing, learn it, that solution is a reducing agent. So Y is a reducing agent. So Y is a reducing agent. Option D is correct. Okay, Y is a reducing agent. Why is a reducing agent? Because potassium manganate is an oxidizing agent, and if potassium manganate changes from purple to colorless, that means that whatever is being added to it is a reducing agent. Just learn that this Ki is used to test for oxidizing agent. If something added to it changes color, is an oxidizing agent. If it does not change color, not an oxidizing agent. And KMnO4 is used to test for reducing agent. If something changes color from purple to colorless, then then that thing is going to be a reducing agent. Okay. Now this is, I guess, probably going to be the last MCQ, because I have to upload this video as well, because you have your exam tomorrow. If I continue to solve the rest 50 as well, that's going to be too late for you guys to see. So I just have to stop here. This is going to be the last MCQ, solving 50 for this one. I try to, solve the remaining 50 and upload it in another video. If you are able to see, if you have time before the exam, you can. But let's keep it till here right now. Magnesium reacts with dilute sulfuric acid. Magnesium, sulfuric acid forming magnesium sulfate and hydrogen. 2 experiments are carried out at 25 degrees Celsius. Okay. Magnesium, 24.0 gram of powdered magnesium is reacted with 100 cm cube of 1 mole per dm cube sulfuric acid. In the next experiment, we have same mass of magnesium, but this time we have double the concentration of sulfuric acid. But are the moles of sulfuric acid same? Because if the moles change, the amount of product can change. But so let's check out the moles. So moles over here are going to be concentration times volume. Volume is 100 divided by 1000, because in cm cube we have to take in dm cube multiplied by 1. So simple. 100 divided by 1000, 0.1. That seems so childish and basic that you're dividing 100 by 1000, but in chemistry, don't take the risk. Always use calculator. Okay, so it's 0.1 moles. Over here, we just have to do the same. 50 times 0.2 divided by 1000. Not 0.2, I'm so sorry, it's 2. So, okay, 50 times 2 divided by 1000. We get the same moles, which is 0.1. So both of them have the same moles. So the amount of product is going to be the same for both. 24 grams, 24 grams. 0.1 moles, 0.1 moles, same amount of product. So this and this option, in which the volume of product, which is hydrogen, is changing, is going to be crossed out. Cross and cross. Because the moles are same, but over here, it has a greater concentration. For experiment 2, the concentration is 2 moles. Though moles are same, but the concentration is 2 mole per dm cube. Over here, the concentration is 1 mole per dm cube. So it has a greater concentration of the acid. So that means this reaction, experiment 2, is going to be a bit faster. And when you have faster reaction, the gradient is going to be steeper. So for reaction 2, which is the dotted line, the gradient should be steeper. Over here, the gradient is steeper. This is steeper gradient. This is less steep. Over here, the gradient is less steep. So for experiment 2, we want a steeper gradient, which is going to be option A. I hope you understood this concept as well. And here we come to an end of our video. So do subscribe to the channel. That's going to mean a lot. And if you did not understand even a single MCQ, just type the MCQ number in the comments and the MCQ, and I'm going to explain it to you again if I could. Okay, so bye bye.